Hey guys, and welcome to the video companion to the Ultimate Tableau Workbook. The Ultimate Tableau Workbook is a workbook that I put together to help you get started with Tableau, the visualization software. I believe that learning is a lot like flying, in the sense that taking off is probably the hardest part, but once you're airborne, there really is nowhere you can't go. This workbook and this course are designed to help you in that takeoff stage, basically get to a point where you're familiar enough with most of Tableau's important concepts so that you can use the resources I give you at the end of the course and know what questions to ask and be able to ask the right questions in the right places. This course is interactive, so I highly recommend you follow along on your own device, and I also recommend that you download the PDF of this workbook, which is available in the description below. One more thing, the colored bar at the top of each page, as you'll see over here, tells you what the purpose of that page is. Orange means the page is about information about the course. This is a workbook that you're supposed to follow along. So blue is for instructions on what you need to do. I offer step-by-step instructions in the guide. The guide is standalone, but the video will also help you. Yellow is for warnings and extra information you should consider. These top three colors are the page that you really should be reading in order to get the most out of the course. Red is purely for nerding out, and this is content that is just there for your enjoyment and stuff that I thought was very interesting. You won't miss anything mandatory by not reading this content, but it's always there for you if you need it. With that, thank you, and let's get started. All right, so let's get started. This is going to just be information that will help lay the groundwork for the course. Why Tableau is important, what does it do, who uses it, and what can it be used for. So what is Tableau? So Tableau itself is actually a software company that's created a host of tools to explore, visualize, and present data. Their three main products are Tableau Desktop, Tableau Prep, and Tableau Server/Online. And then within these products, you usually have a couple of offerings. So Tableau Desktop is the core product in Tableau's portfolio, and it's what most people mean when they refer to Tableau. It is the desktop application that runs on either Mac or Windows, and it allows you to create professional-grade visualizations very quickly. At its core, it's a visualization software, but that means a lot more than people usually think it means. Within Tableau Desktop, you have Tableau Desktop Public Edition, which is just a free version of the desktop software that contains all of the functionality of Tableau Desktop with the exception of a couple of things here and there. But anything you publish on that can only be saved to Tableau's public cloud. So in exchange for having a completely free version of their software, you can't save things to your desktop. Tableau Prep is a tremendous tool that Tableau released, I think, like a year or two ago, that is data cleansing software. If you've ever used Alteryx, then you'll get a basic idea of what some of Tableau Prep's functionality is. It comes free with every license of Tableau Desktop, and it is Tableau's answer to the question of what do I do if my data is not fully prepared and fully cleaned? So whenever you work in Tableau, you always bring in data, and then you visualize the data. But anyone that's worked with data will know that a lot of time is spent cleaning up data and getting it in a format to where it's easy to visualize. Tableau Prep helps you take care of that. It's a complete GUI-based interface, no coding knowledge necessary, and it's designed to let users easily and visually inspect data sets and clean them systematically before they're visualized in Tableau Desktop. Everything that's made in Tableau Prep is part of a workflow that allows you to link parts one after another to do different steps in your data cleaning workflow. It is a tremendous tool, and I do hope to make a course on it at a later time. Tableau Server or Online is it's basically a server that allows you to publish Tableau visualizations and distribute them across the company. So if you work at a company that has a Tableau deployment, they will probably have a server, and this is what allows people that design visualizations in Tableau Desktop to distribute them to other users in the company. And this is key to a successful deployment of Tableau. Without Tableau Server or Online, you're going to have a very hard time having fully accessing the power of the visualizations you make in Tableau. So, what is the importance of data visualization? We call Tableau a data visualization tool. Why should you care? Well, the importance of data itself is not lost on anyone. Data visualization at its core is, and I'm going to skip to the end of here, it's just the process of abstracting away the complexity of raw data and organizing it into a form which we can more easily consume. That's a very powerful definition right over there, because data has been called the oil of the 21st century, and like oil, it's not very useful right out of the ground in its raw format. If you've ever seen crude oil, no one can really use it for anything, and it definitely cannot be sold at its full value right out of the ground. The real value in oil or data is when it's been refined and when it's been organized. That way, people can really derive, in the case of oil, power, or in the case of data, insights from it. Data itself is not useful. It's what data can tell you that's useful. And data visualization is one of the key ways that you can unlock insights when unlock insights from data. A really great example of this is something called Anscombe's quartet. So if you work in analysis, you'll know that a lot of data analyses start off with the measures of central tendency, where basically you'll take your table and then you'll you'll take your table and you'll take these measures right over here: the mean, the median, the mode. The mean is the average of all of your data points. The median is the center of all of your data points. These two are not necessarily the same thing. And the mode is the most the value that appears the most in your data. Anscombe's quartet is a series of 4 data sets that have the exact same mean, median, and mode. While they have the exact same mean, median, and mode, when you visualize the data, when you actually plot it, you'll notice that the distributions are completely different. This is not something that a couple of statistics will immediately tell you, and it's but it's so much more obvious when you visualize the data. The importance of data visualization is that it'll help you see patterns where they may not obviously exist when looking at it in its raw format. And it is a key way to start any analysis of any data, and is what Tableau excels in. So what makes Tableau so great? Data visualization is not something that Tableau is the only company to be working on, but what makes Tableau specifically so good at what it does? So for those of you that are not aware, Gartner is a research firm that specializes in giving IT leaders information on where different software products are operating in their space. Basically, how competitive are they? And they release, I believe every year, for different types of software products, something called the Gartner Magic Quadrant. It is a series of, 4 quadrants that have 2 axes, one called the completeness of vision and one called the ability to execute. The completeness of vision is basically, where does this company see itself going in the next X years? Ability to execute is, how close are they to actually realizing that vision? As you can see, Tableau is in the leaders quadrant. This is usually the most desirable quadrant to be in. Gartner is very specific that you should look at every product by its own merits in relation to what you need. And that's tremendous advice. But this gives you a basic idea of how well Tableau is competing against everyone. Not only are they in the leaders quadrant, they're far ahead of everyone except for Microsoft, which my opinion on this is very much that Gartner biases companies with very large product portfolios. That's where the ability to execute and the completeness of vision come in. And Microsoft, being Microsoft with Azure especially, and Azure ML and all the new tools are releasing on that, has a much bigger product portfolio than Tableau. But either way, Tableau is a best-in-class tool and something that is used all over the industry. More specifically, as a user, as someone who's used Tableau over the last couple of years, my opinion is that customer enthusiasm is probably where Tableau really outshines its competitors. There are many tools in this. Space, a lot of which I've used and a lot of which I've heard other people use. And it's not very often I hear people liking what they use as much as people like Tableau. The user groups that they have all over the country, the forums, the knowledge base, the documentation, everything is top-notch, and it is a tool that is not only well supported technically, but is very well supported by its user community and by the company itself. We were a smaller account for Tableau in the Dallas area where I work at my older company, but the attention we got from the Tableau account executives was amazing. I absolutely loved it, and I can say as a product and as a company, Tableau is great. So why should you learn how to use Tableau? Well, Tableau specifically, actually, and this is just these are just salaries for a Tableau developer. But Tableau, the job opportunities, if you have good Tableau skills, and the pay that you can get if you have good Tableau skills is very solid. Now, obviously, these are two very different numbers. These are two very different numbers. But as you can see, a Tableau developer gets paid a very solid salary. This is not anything to laugh at, and the job opportunities are quite numerous if you have Tableau skills. And probably the best thing about Tableau is that almost anyone can benefit from it. So they call data the oil of the 21st century, and the number of insights that you're able to derive from it are such that data should not only be used by data professionals. People in all walks of business really should be using it. When I went to Tableau conference last year, one of the most interesting stories was about a doctor who was using Tableau to more accurately diagnose or find patterns with some of her patients to find out that they were being diagnosed not in the most accurate way possible. I'll see if I can find the link to that story and link it below. But just in my experience, I've seen Tableau used by account managers, supply chain directors, warranty managers, and myself as a data analyst. Account manager, the example I have is that when I was working at my old company, we had a account manager who was in charge of a very large, very important account. This account was many times larger than our actual company. So keeping them happy was very important. And they demanded a very high level of service because they were a very process-oriented company with an excellent sense of process. Tableau helped us diagnose or plot and prioritize any problems that we had with the account geographically. That way we could service them to the best of our ability. When I was working at my old company also, the C-level executive who came in to help out, or that came in to lead our department, he expected there to be a weekly report out from the directors on all the metrics on any metrics that they decided to collect for their team. And our team was able to automate the process of gathering, calculating, and visualizing these metrics using Tableau and Alteryx. And you'll hear me mention Alteryx a couple of times too, because that's a tool that I'm very familiar with. This reduced, so we spent maybe a day or two working on this, and this reduced what would probably have been a couple of hours long process every single week, gathering the data, calculating, and visualizing the metrics to something that just happened on a regular basis. In fact, this was so successful that we were asked to do this for the entire department, and by the time I had left, we had automated the metrics for all of the directors in our department. We had a very special warranty metric at my old company, and Tableau really helped us. It helped us by automating that process of calculating this metric, which took a full-time employee a quarter of the month in order to calculate on a regular basis. But Tableau made it to where we could not only calculate this quickly, but after we were able to calculate it very quickly and visualize it very quickly, we could, because the process was so much faster, we could parlay this metric into other calculations that other people in the company were doing to rapidly speed up and improve the quality of our analysis across the enterprise. And then as a data analyst, I would say probably the most surprising benefit of Tableau is the ability to explore data. Data exploration and exploratory analysis are two big things that I've always been asked to do. And Tableau has made my job in that space much easier by allowing me to look at data in a very visual and intuitive format. So VizQL is a technology that forms one of the core technologies that forms the back end of Tableau. We're not going to go too much into depth with it, but basically just know that it's a querying language that Tableau uses. If you're interested, feel free to read this page on the PDF. And the Hyper Database System is just a database system that Tableau bought out in 2016, I believe, that makes analyses much, much faster in Tableau. And anyone that has done a lot of analysis will know that you can spend a lot of time just waiting for queries to run and just waiting for extracts to be taken out. The Hyper database system makes this process so much faster, and it's amazing. All right, so to participate in this course, I highly recommend you follow along. You will need to install Tableau. So a lot of you will have Tableau installed because of your workplace. You can go to tableau.com and install it there, a 2-week trial of the full version of the software for 2 weeks, or you can install Tableau public version. Just remember, if you use Tableau public version, don't put any data in it that you wouldn't be comfortable going onto a public server, because that's all the visualizations you make over here can only be saved onto a public server. The entire course can be done on Tableau Public. I'm actually going to be demonstrating everything on Tableau Public. So don't feel like if you're using this, you're not getting the full experience. All right, with that, let's get started with section 1. I will see you guys soon. Hey guys, welcome back. So this is where we actually start section 1 of the course. So before we start, make sure that you have Tableau downloaded, installed, and open. And also make sure that you have the datasets downloaded somewhere where you can easily reach them. So assuming you have those two things, we can get started. So when you open up Tableau, actually let me close this. Oh, whoops. Did not mean to do that. How do I open that up again? Let's go here, here. Hopefully it just opens up the exact same way. Close. So, put that over there. There we go. And now I need to open up Tableau. Go. Takes a second. All right, there we go. Oh, looks like I sized it perfectly. So when you first open up Tableau, you will be directed to somewhere called the Connect menu. And this is where you connect to data. So if you have the PDF, which again you can download right here, you'll see a small anatomy of the Connect menu. And just to go over it, basically, this side over here on the left, this is a sample of the data sources you can connect to. This is Tableau Public. The version of Tableau that I'm using is Tableau Public. So because of that, there's a limited number of data sets I can connect to. But that's okay. This is all we'll need for the course today. And if you click on that, then you can see that there are more things to connect to. All right. And then over here, you'll see this will be populated with, if you've used Tableau, any workbooks that you've created over, any workbooks that you've created. And the right side is the Discover tab, where you can get a couple of how-to videos to get started, the visualization of the day, any updates that you might have to, whenever you have to update Tableau, and then some resources. One thing that's really cool is the sample datasets button over here. So you can see that Tableau has quite a few data sets that you can use for free. I highly recommend this if you're looking for any practice with Tableau. But for this course, I've created some custom data sets just for you guys. So let's go ahead and get started. So like I mentioned earlier, we're going to be working with a data set from the Chicago Department of Transportation on filming permits that they have approved. So it is a Microsoft Excel document, and let's connect to it. So over here, click on Microsoft Excel, and then find, let's see, there we go. Find the Chicago Films data set. I believe that's what it's called. Chicago Filming data set. There we go. Should be about 5 megabytes large. Give Tableau a second to process the data. And here you go. Now you are on the data source page. So earlier we were on the connect menu, and when you are working with Tableau, you have to the way you think about your process is you first create a data source, and then you start making your visualization based on that data source. So connecting to data is the first step of creating a data source. Now, we imported a Microsoft Excel workbook, and Excel workbooks can have a large number of sheets on them. I'm not sure if there's an actual limit, but because of that, you need to tell Tableau which sheet to bring in. So let's go over here. We're going to want the Chicago filming permits sheet. So this one over here. So all you do, you take it and you drag it over here where it says drag sheets here. And you can see now the screen is transformed a little bit to where this is the canvas in which you create your data source in. And for now, we're just going to have this over here. But later in the course, we'll do more complicated stuff with this area. This section over here, sorry, let's start over here. This section over here, these are your connections. You can have multiple connections. As you can see, I can add a connection over here, and then I can bring in another data source. Again, later in the course, we'll talk about what exactly you would use that for. And here are all the sheets associated with this connection right over here. If the data you're bringing in doesn't look right or isn't imported correctly, because Tableau will by default just import it however it's saved, which, for example, say the first 5 rows are completely empty, then you'll see that over here in your data preview window. You can use the data interpreter, which what that will do is that will it basically intelligently tries to determine what you're actually trying to import. So I cleaned up this data set for y'all, so you won't need to worry about that. But if the data over here doesn't look correct, then using the data interpreter might be a good idea. So let's see, what else is there to show you guys? You have your data preview over here, and you can see that we have quite a few columns. The columns are listed over here. The rows are over here. Tableau by default will show you 1,000 rows of data, but you can change this to be whatever you want. So I can make it 10,000 if I want, or really as many as I want to. But you want to keep this as small as possible. That way you're not just bringing in a ton of data for no reason. You have your filters over here. So these are what you call data source filters. And later in the course, we'll talk about what are all the different types of filters you can use. A data source filter is basically if you know you don't want some data at all in your visualization, then you can insert this filter right over here, and Tableau will filter out the data before bringing it in. This can really, really speed up the amount of time that it takes your data to load. And this over here is just another way to cycle through your connections, this little database over here. So let's go ahead and get started. Click on Sheet 1 down here. You can see Tableau automatically tells you where to go. And I give you a small anatomy on this PDF right over here. All right. So now your screen should look something like this. You'll see this is where you'll probably spend most of your time in Tableau. So this is called the Tableau workspace, and it can look a little bit intimidating, but it's actually quite simple and quite intuitive. So let's go through it bit by bit. So you'll notice over here on the left-hand side, you have this button over here. This is the Connect menu. So you click on this, and you go back to the Connect menu, which is how we started off Tableau. And then if you go down here, you'll notice there are 2 tabs, Data and Analytics. Data is what we're going to be sticking to right now. Here is the data source that we brought in, Chicago filming permits. So that is the name of the workbook. This is the name of the sheet. And then below that, you'll see all the different columns that we have in our data. And you'll see that they're split into 2 different sections, dimensions and measures. Later, we'll go over what the difference is between those 2. This button over here lets you see all of your data all at once. So you can take a quick look at it if you need to. And by default, it shows you 10,000 rows of data. That way you're not, if you're connected to a large database, you're not just bringing in a million rows all at once. This over here is how you can create different fields and different types of tools that we'll be using later. So we'll not worry about that right now. But just know these are where all of your columns are. Dimensions and measures are how you split them up. Over here, you might notice this looks kind of like a pivot table. This is where you can drag these columns in to create columns and to create rows in this area over here. You can also drop the fields right over here if you want to. If you want to make it a column, if you want to make it a row, or if you want Tableau to figure out where it's best, where that data best belongs. You have your filters over here and your marks card over here. We'll go over these two a little bit later. Over here on the upper left, you'll see this back button and this forward button. This is an undo button and a redo button. Tableau has something called infinite undo, where within one working session, basically from when you open up Tableau, you can undo an infinite number of times. So this is a tremendous tool, and just know that there's almost nothing you can do in Tableau that you can't undo, which is incredibly helpful. And then the same applies for the redo. Obviously, you have your save button right over here. This is to connect to a new data source. This is to create a new worksheet or a new dashboard or story. We'll go over what all those are later. This is a sheet over here, by the way. As you can see, sheet 1. This is to duplicate the current sheet, and this is easily one of the most used functions I have in Tableau. It really helps me with exploratory analysis when I can just keep duplicating sheets and iterating through the data in different ways. And then we have a couple of more buttons over here that we'll go through later. And then this is the Show Me button, which basically, given the data you put on the canvas over here, it will highlight the different types of visualizations that you can easily make. And as you can see, if you hover over things, so for example, like a bar chart, you can see that it's asking for at least one measure. And I don't necessarily need dimensions. Again, we'll go over what all those terms are later. All right, so time to manipulate our data. So although Tableau is quite intelligent, sometimes data is imported incorrectly. So one example I can show you is wards over here. So wards is actually, you can see it's a number and it's under measures. I'll explain what that is in a minute. It's not supposed to be here, I can tell you that. So wards refers to basically a section of Chicago. I believe there's about 50 of them. And each of them has a, I believe alderman is the term for the head of a ward. But basically, Tableau imported this data incorrectly because it's completely numerical. It put it down here. So what I want you to do is to click on it, click and drag this up to dimensions, and then drop it. So you can see just by doing that, we've moved it from measures to dimensions. And I'll show you exactly what that does in a minute. Oh, and just as a note, inside this workbook, all the column names will be inside brackets. This just mirrors what SQL and what Tableau, how you specify a column in SQL and in Tableau. So there are 4 types of data inside Tableau. You have dimensions and measures, and then within dimensions and measures, you might have noticed that some data is blue, as in some of these labels are blue, and some of these labels are green. Let's see if I can find an example. Okay, so it looks like we don't have any green data here or blue data over here. But basically, a dimension is any qualitative data that you might have. So that's like names, colors, cities, anything that's not numerical, not a number that you can perform math on. And perform math on is important because just because something is a number doesn't mean it's quantitative data, which is the exact opposite. So you have dimensions, which is your qualitative data, and measures, which is your quantitative data. So this is basically anything that you can perform math on. A good example of something that is a number, but it is qualitative, is a zip code. Your zip code might be 75251. Zip code are postal code for our international viewers. Your postal code might be 75251. But that might be a number, but that is not a number you can perform math on. It is not qualitative data, or it is not quantitative data. It is qualitative data because there is no 7525.1. You can't divide it infinitesimally. That's one determinant of a measure or quantitative data. So population or profit are examples of measures or quantitative data, and that's what will be classified over here. So we actually moved wards from here, measures, up to dimensions, because although wards are numbers, like so you can live in the 1st through 50th ward in Chicago, you can't perform math on them because there's no 40.5 ward, or you can't add up wards 1, 2, and 3 and get ward 6. It's just a number, and the number itself doesn't really mean anything except for a classification. It's the same as a name, basically. So that's why we moved it up to dimensions. So one key thing to remember over here is that although Tableau is quite smart, whenever you work with data, you always want to inspect it before you start working to make sure that the data was imported correctly. So this is just a simple example of how we can fix that. Oh, and sorry. And then data can either be discrete or continuous. Whoops. There we go. It can either be discrete or continuous. In Tableau, blue, so these blue pills over here, or these blue icons over here, represent discrete data, whereas green represents continuous data. Continuous data is data that is infinitesimally divisible, whereas discrete data is data that is not infinitesimally divisible. So for example, you can't have a 40.5 ward, but a fee can be basically any number 1 through 100, and same with waived fees. And census tracts is something that we should probably move up here too, but we also won't be using that, so it doesn't really matter. I believe that and that can also be moved up there. But we won't be using that in our analysis today, so I wouldn't worry too much about it. And let's see. So given that data can be either a dimension or a measure, and then it can be either discrete or continuous, you can then have discrete dimensions, continuous measures, continuous dimensions, or discrete measures. Now, the most common form of data you'll have are going to be discrete dimensions and continuous measures. As you can see over here, discrete, blue, dimension up here, basically everything in dimensions, or in this case, everything in dimensions, is discrete. It is blue. Whereas most of your measures are going to be continuous. This is because a measure is purely something you can, measure, perform math on, and most things you can perform math on are continuous. And most categories, which is, what a dimension is, you can't perform math on them. That being said, that doesn't mean that you can't have a continuous dimension or a discrete measure. Later in the course, we'll probably see some examples of that, but not for now. So let's get started. Let's make our first visualization. So the most basic form of visualization is a table, something with 2 axes that just has all the data filled in inside it. It's not the best type of visualization out there, but it is something that gets the job done and is often necessary. So let's get started. All we need to do, as you can see, Tableau is a drag and drop interface. You can just drag in whatever you want, wherever you want, and then stuff will automatically fill up as needed. Put that over there. And then obviously you can undo it if you want to. So let's get started. Tableau, as you can see, actually will imitate certain behaviors of a pivot table. So let's drag application start date from dimensions to the columns shelf up here. So application start date, as you can see, is a date, and we're going to go over what these icons mean a little bit later. So just drag and drop. And you can see Tableau automatically gave you different columns with each at the year level of this date data. You can change this as you please. For now, we'll just leave it as is. Then let's drag wards into rows. So remember, we converted wards. Let's drag that into rows. So as you can see, Tableau expanded it to where our application start date is a column, and the rows on the left-hand side are your wards. And these ABCs over here basically signify that there is no data inside this in this section over here, which makes sense. We only defined our row and column, but not what is actually inside the table. So let's do something about that. Let's drag the column or the measure number of records to text under the marks card. So if you go all the way down here, number of records, as you can see down here, the marked card, that's this part over here. Then we go to text, put that over there. And as you can see, we very quickly populated our entire table. So application start date under columns, wards under rows, and number of records under your text area of your marks card. And you can see we've created our first visualization. Congratulations. If you have ever used Excel pivot tables, and you'll notice that this is very similar to how they work. So the Tableau borrows a couple of abstractions from Excel and from SQL, and these just make it very easy for you to switch back and forth between all these tools. So I find it quite useful. So next, let's try and create an actual visualization, something like a bar chart. And although they are very basic, bar charts are some of the most effective visualizations you'll have in your toolbox. Don't ever skip on a bar chart just because you think it's boring. They are tremendous for showing people data, showing people insights very, very quickly. So if you look down here, you'll notice that our sheet title is down there. Let us rename this to something more topical. So let's call it Applications by Ward Crosstab, because this is what you call a crosstab. So just double click sheet 1 and then type in Applications by Ward Crosstab. And you can see Tableau automatically changed that title up here too. You can always change this title up here too by double clicking this. And you can see it just copies the sheet name right now. I can change it to whatever I want to though, if I want. But for now, we'll keep it as Applications by Ward Crosstab. And if I change it to something else, then Tableau will reflect that change up here too. So very convenient. All right. So now we're going to use that duplicate key that I was talking about earlier. So go up here, just hit duplicate or duplicate. This is a duplicate that we made using the duplicate key. Let's call it that. So as you can see down here, we have a new sheet. Obviously, Tableau needed to call it something else. So let's change it to Applications by Ward Bar Graph. Another way to make a duplicate is to right-click and then just click duplicate. So you might think that we might have to go through some effort in order to make a bar chart. Not true. Tableau makes it really easy to iterate through different chart types. Like I said earlier, this Show Me tool over here is amazing and will show you all the different types of graphs that you can make given what you have on the canvas right now. Click on this bar chart icon here and you'll see Tableau created a bar chart for us from our table, from our crosstab. And then what we want to do is we want to sort this by the most recent year. So go to 2019. As you can see, when I hover over these, they highlight, and then click on that button right over there. And then it'll sort everything in descending order by number of records by 2019. So we can see Ward 42, it seems every year actually, had the most applications turned into it for film permits. And if you know what Ward 42 is in Chicago, you'll understand why. This is basically where the most iconic scenery of Chicago exists. So that's why Ward 42 would have the most applications sent into it. So as you can see, with almost no effort at all, we created a brand new visualization and was able to sort the data by 2019 in order to see exactly which ward brings in the most filming permits. So congratulations, you've created your first real visualization in Tableau now. Okay, so now let's do something a little bit more interesting. We're going to work with something called geospatial data. This is basically data that is plotted on the surface of the Earth. And geospatial analysis and geospatial data is all the rage right now. People love seeing maps of things. And I find that the very simple maps you can make in Tableau are things that people find very useful and very insightful. So let's go ahead and duplicate this chart again. Oh, sorry, no, let's not do that. Let's just create a new sheet by clicking on the New Sheet button. So you'll see down here where we have our sheets, this leftmost button over here, this is to create a new sheet. So click on that. And then let's drag latitude and longitude into rows and columns respectively. So don't use latitude generated and longitude generated, just use these two over here. So latitude into rows, latitude into rows, longitude into columns. And you can see Tableau will automatically turn it into a map. Now be careful, if you do it the exact opposite way, longitude into rows, latitude into columns, then you'll actually get a scatter plot, which you don't want. So remember, latitude into rows, longitude into columns. And you can see what Tableau does is it takes all of our points, because we haven't told it what exactly to graph yet. We just told it latitude and longitude. So it takes all of our points and it finds the center of every record we have in our database right now, which is, somewhere in the middle of Chicago. So what we want to do is we'll take application number, this should actually be in brackets, into the details box of the marks card. So application number, where are you? There we go. And we'll drag it into the details, or the detail box of the marks card. And you might notice that this warning comes up. This warning is designed to stop you from just adding way too many records to a visualization all at once. You might find that eventually you start working with so much data that you will actually lose hours of your day just waiting for things to process, which is why Tableau gives you this warning. In our case, we want all of the data, so click on Add All Members. And congratulations, as you can see, if you scroll out, we've created a very basic geospatial visualization. If you scrolled out and you want to get back to that view we were at, just click on this pin over here. There we go. All right, so we should have something like this. This just goes over what happens if you switch these two. I can just show you using this button over here. You'll get something like this, because latitudes need to go into rows, longitudes need to go into columns. I'll leave you to figure out why that is, but there's a specific reason you need to do it that way. All right, so wait, not yet. Let us go over here. This, okay. Okay. So as you can see, this map is obviously not particularly useful. It's just a bunch of blobs everywhere. So let's see if we can visualize this ward by ward. So let's give each of these dots a color corresponding to the ward that it is in. Now remember, each of these dots, also called a mark, represents a application number, as you can see in the tooltip over there. Department of Transportation, number, and then the latitude and the longitude. So let us take wards and then drag it here into colors under the marks card. Add all members. And as you can see, we now have a much better view of exactly where all of our film permits were, where they were requested. And then what you can actually do in Tableau is you can click on any one of these, and it'll highlight automatically all the marks corresponding to that number in the legend. Remember how I said Ward 42 is where all the big stuff in Chicago is? Yep, as you can see right over there, that's exactly where everything is. If you think Chicago, you're probably thinking about this area over here. So let's rename this sheet to Application by Ward Map. Actually, it's called Applications by Ward Map. All right. And this is something I highly recommend you get in the habit of doing. naming sheets accurately as you're creating them. I can tell you from experience that it is very tempting to make a bunch of sheets with a bunch of different visualizations and not name things as you're going along, or getting rid of sheets you're not using. And that can lead to some very messy workbooks very quickly, because Tableau just makes it so easy to just keep iterating and iterating and iterating. So I highly recommend that you name your sheets accurately as you go on. I will be the first to admit it is a habit I need to build myself. You might notice some errors inside this PDF. I'm noticing them as we're going through the PDF right now. I'll definitely try and get them fixed before I release this fully. And if you notice any improvements that I can make either to this course or to this PDF, feel free to let me know. All right, let's make a dashboard. So when you start working with Tableau, you'll probably get a lot of requests to make dashboards. Of course, dashboards are not the only thing that Tableau can do. Like we're showing over here, you can do exploratory data analysis. But a dashboard is one of the most common deliverables that people are asked to create when using Tableau. So let's create a new dashboard. Click on the New Dashboard button. It is near the New Sheet button. This one over here, the one with the 4 squares. Click on that. And you might notice that you get this view over here that says Drop Sheets over here. And this is what your dashboard will look like size-wise. This is kind of weird. We're creating something for the desktop, and so we'd want something that is shaped a bit more accurately for a desktop view. So the easiest way to fix that is to go to Size, under Size, click over here. This might say something else just depending on your configuration of Tableau. Choose Automatic. And you'll see Tableau will dynamically resize everything, and it'll resize any visualizations you put in there to more accurately reflect, or to accurately reflect whatever screen it's being viewed on. All right, so time to double-click Applications by Word crosstab and Applications by Map, by Word Map, in that order. So if you can't see what it is, obviously if you just highlight, then it'll show you a preview of what this visualization is. Very, very useful for when you've created like 20 sheets and you need to know what's what very quickly. Alternatively, you can just drag this out over here. So what did I say we needed? We wanted crosstab, so just double-click that. And you can see Tableau automatically put it over here. And then Applications by Word Map, double-click. So Tableau will put it where it, based on the size of your screen or your window, where it thinks it'll best fit. Because I shrunk this window a little bit in order to make room for this PDF, it put it down here. If you want it on the side, all you have to do is click, go to this grab handle over here, and look for this 4-way arrow. Drag and, drag and drop. And you see it more closely resembles what I have over here. And congratulations, you've made your first dashboard. So this is one of your very basic analytic deliverables. This is the kind of stuff that people will be asking you for a lot of the time with Tableau. And the point of this was just to get your feet wet and show you and get you comfortable with how Tableau works. It's drag and drop for a lot of stuff. And almost everything can be done with just your mouse. It's very easy to understand, very easy to use. If you got caught up anywhere, again, remember, Tableau has unlimited undo. You can undo all the way back to the beginning of this workbook, as you can see over here, where we have basically nothing, and then redo all the way to that point too. So if you feel like you've messed up or what you have doesn't look like this, don't worry, just undo. Go back in the video to where you need to and just copy what I did again. If you do exactly what I did, then you should get this same result over here, or something very close to it, really. I find that until you release things to the public, you never really know how things are going to turn out. So you might want to save your workbook over here. If you have Tableau Desktop, just the full edition, then it's very simple. Just File, and then you'll have a Save As option over here. Just save it as a .twb file. you can just save the workbook over there. It's quite simple. If you have Tableau public, then you have to save it to the public cloud. So you click down, save to Tableau public as, and then a screen should pop up, where you name it, and another screen will pop up asking you to log in. I'm already logged in, so I don't think that screen will pop up for me, and I already have this saved, so I don't need to save it right now. So before we end section 1, let me explain what sheets, dashboards, and stories are. So those are what these 3 buttons down here are. A sheet is the most basic workspace in Tableau. This is where you will create your visualizations, your base visualizations. A dashboard is usually a collection of sheets, and this is where you can put them together to create an interactive dashboard with many different sheets and many different different types of visualizations for anyone that you're creating dashboards for. A story is something that, I'll be 100% honest, I've never used. I'm not saying it doesn't have a use, but basically it works kind of like a PowerPoint presentation, where you can add like a sheet over here or even a dashboard, and then continue to add different, let's see, no need right now. You can add a title over here, and then just add more and more, what would you call them? Story points, one after another. And then you can present it kind of like a presentation. So this is excellent if you end up presenting a lot of stuff, a lot of analyses to people. Usually I just present mine in the form of screenshots, or I will build a dashboard for someone and I want them to play around with the dashboard, not the story. So that's what sheets, stories, and dashboards are. For more detailed information, obviously take a look at the PDF that I have. It might have more detailed, more information laid out in a clearer way that'll help you go back and look at exactly what we what each of these things are, the definition of each of these things is. So there's something called the 7 data stories, and this is just a very interesting concept. The basic idea being that there are basically, whenever you're doing anything with data, you're really trying to tell a story with it. And there are 7 different stories that you can tell. You can basically show someone change over time. You can drill down to a point. You can zoom out for a point, compare and contrast 2 different things, show the intersection of 2 seemingly unrelated categories. This, in my opinion, is one of the most interesting types of data stories. Show what drives a certain phenomena, and what are outliers in data. Again, this is another one of the very interesting types of data stories. For a more expanded view on this, feel free to follow this link. But I want to stay on topic with this course and show you guys basically how to use Tableau, what I think is best communicated through a video. But if you guys want to see more stuff like this, like the more abstract concepts of creating data products, then let me know, and maybe I'll create a video about it. So congratulations, you've completed section 1 of the course. And in my opinion, there's no better way to learn than to do, especially something like Tableau, which is very drag and drop, very kinesthetic. I 100% believe that doing is the best way to learn. If you have any questions about specific functions inside Tableau, hopefully we'll go over them in this course. If we don't, then kb.tableau.com is your best friend. This is the Tableau knowledge base. And it took me way too long to figure out this thing existed. But basically, this has all of Tableau's documentation on all the different things that you can do inside Tableau, and it's very, very thorough. And I think it's one of the reasons Tableau is such an amazing tool. Their documentation is excellent. So this is going to be one of your best friends when you have questions. This in the Tableau forums. I have encountered maybe just a thing here and there, that a problem that someone else hasn't had. The user community is very active. And if you have a question and you post it, provided you did the research, people will respond to you very quickly. So congratulations, we've finished section 1. And we've covered quite a bit. We've gone over what exactly Tableau is, the importance of data visualization, what makes Tableau so great. In my opinion, it's the user community. That's the one of the best parts about it, the part that's hard to duplicate. The ease of visual exploration and VizQL. This is that section that we kind of skipped over, but is available in the PDF if you want to read more. The hyper database system, in my opinion, this is a very interesting read. Again, not something that you'll benefit from hearing over video. I might leave a link to a excellent speech, an excellent talk that was given at Tableau conference about the hyper database system. Very interesting. How to install Tableau. Obviously, if you've come this far, you probably know how to install Tableau now. Connecting to static data. This course will only go over connecting to static data. We're not going to connect to any live data or any server data, only because this is so variable how this works that I'm not sure I could communicate how to do that very well over a video. The anatomy of the Tableau data page. The Tableau data page is this page over here. The anatomy of the Tableau workspace. That is any of these pages over here, this sheet, for example. Cleaning data, that would be, an example of that would be when we turned our wards from a measure into a dimension. Dimensions versus measures. Tables, bar charts, and geospatial data. Basic troubleshooting, what to do if you have a problem, where to go. Resizing dashboards, that's where we change this size to be automatic. Saving your work. Sheets, dashboards, stories, and the 7 data stories. So that is the end of section 1. If you want to take a break over here, now is a great time to do so. And I will see you in section 2. Hey guys, welcome to section 2. So the objective of this section is to try and create more advanced visualizations. We're going to do we're going to tackle a more advanced problem. In Chicago, independent films only need to pay a permit price of $25 per day per location, whereas big budget films need to pay $250 per day per location. We're going to use this information to try and classify permits as either big budget or independent. So if you open up a new sheet, you'll notice that we actually don't have anything here that says big budget or independent. Basically, there is no way, given the data set we have currently, to tell what films are independent or big budget. So this section assumes that you've completed section 1 and that you have your workbook saved from there. If you don't, you can download a copy from here. So this will just take you to Tableau Public, and you can just download the workbook, and you'll be exactly where we are right now. Something might be renamed or something over here, but it should be the exact same thing. So make sure that you have all of section 1 done before you come here. So there isn't actually a field that tells us if a film is a big budget or independent film. When you don't have the explicit field you need, you might be able to derive it using what we call a calculated field. And remember, when I use the word field, I'm referring to columns. A field is just another word for a column. If you look at our data set over here, you'll notice each of these columns is what we call a field. So let's go ahead and create a calculated field. Go up to, So what we do know is we know big budget films get charged $250 per day of shooting, while independents get charged $25 per day of per shooting. We also know what fees a movie was charged through the column total fees. And a quick pro tip, you can find a field by clicking on that magnifying glass over there and just typing in the name of the field. This is really helpful for when you have a lot of fields that you need to look through. So films can also have some of their fees waived, and this has to be taken into account through the waived fees field. So create a new sheet. I already have one. And under the analysis menu button, click Create Calculated Field. So up here, If you're on Windows, it should be like over here at the top of your menu bar. Click Analysis, and then go down to Calculated Field. Oh, whoops. If you're using multiple screens, then it might show up on a different screen. So you might get something that looks like this, a separate window. Click on this arrow over here in order to expand it and show the assist menu. And then let's resize it a little bit. All right, so name your new calculated field days spent shooting, because if we want to know if a film is big budget or independent, we need to know the fees per day. We don't have a column over here that tells us how many days they've been shooting. We only have the start and end date. So use the following formula. You can always just copy and paste it, and I will explain exactly what it is, what we did in a minute. All right. And then we need to name the calculated field days spent shooting. So this is where you name your calculated field. All right. There we go. You can see the whole formula now. So let me just go through what exactly this calculation does. So this window over here is your calculated field window. Over here is where we name our calculated field. This down here tells you if your calculation is valid or not. If I, for example, take that comma out, you'll notice that it says calculation contains errors. This white space over here is where you actually write down your calculation. You'll notice that it comes up in a different font, a monospace font, from the rest of your everything else in Tableau, basically. This is how you know you're writing down a calculation. You then have your apply button and your OK button. The apply button is great because sometimes you'll want to modify a calculated field and see what the modifications you made do to your visualization. So you just hit apply and the window will stay up, but you can see what changes were made. So you can see, for example, days spent shooting is now down here. We created a calculated field. And Tableau was smart enough to realize that this is a number and a measure. So let's go through the actual calculation. Oh, and another thing, this over here explains exactly what the function you're using does. And this over here is a list of all the functions available to you, classified under this dropdown. So we use what we call the dateDiff function. So dateDiff is just, it is a function designed to tell you the difference between two dates at whatever level of, for whatever time period you want to determine it for. So for example, the first thing you put in is your date part, either day, month, week, or year. So I can change this to month, for example, and that would still be valid. Now, this function, this dateDiff function, will tell us how many months have passed between our start and our end date. But we want day. You'll see over here, application, oh, let's go back over here. You'll see the second part of our formula, and you'll see it has this awesome assist tool over here. This is the start date. For us, that'll be the application start date. Then you have your end date. So basically, from when to when do you want to measure the number of days that have occurred. So one interesting thing about this data set, this is actually a real data set. You can download something very similar to this from the Department of Transportation website. I've modified it slightly just to make it easier to use. But in this data set, the application end date and the application expire date could be the date that the application lasts until. So we want the later of these two dates. So what I did is I wrapped these two inside this max function over here, which you can see just returns the maximum of a single expression across all records or the maximum of 2 expressions for each record. So basically, what it does is it'll return whichever one of these is higher. And it'll take that date, all 3 of these are dates, and it'll tell us how many days have passed between the application start date and the application end date or expire date. We then have this +1 over here. So this +1 over here exists because we want to make sure, so for example, if an application started and ended on the same day because it was shot in one day, the date difference over there would be 0 when really 1 day of shooting occurred. So we want to add that 1 over there. So here's just a quick explanation of exactly what is what in our calculated field. So congratulations, you've just created your first calculated field. Now, calculated fields are easily some of the most powerful tools in Tableau, and as such, they can also be some of the most confusing. I would not be lying if I said I haven't spent just hours trying to figure out a single calculation before, but they can really change the game as to what you are able to do with Tableau. There's really not a lot you can't accomplish with them. All right, so we know the number of days that were spent shooting, and the fees we need to figure, and the fees. So we need to figure out the fees per day. So if you see over here, we have 2 fields for fees, total fees and waived fees. So let's create another calculated field. So let me shrink this a little bit. Again, you can just copy and paste here. There we go. And you'll see everything is exactly as it should be. Tableau will automatically highlight all your fields in orange and any formulas in blue. There are a couple of other things that are different colors in this window. For example, when you bring in a parameter, which we will go over in section 3. I believe parameters are purple, if I'm not mistaken. Just to give you guys a small taste of what's coming up, a parameter is basically a constant value that you can change whenever you want, but let's not worry about that for now. So what this function does is it takes the total fees and then subtracts any waived fees. And then you notice how this is inside parentheses, and then divides it by the number of days spent shooting. So you basically get fees divided by days spent shooting to get the fees per day. That way we can decide if it's $250 or if it's what would you call it? If it's $250 or it's $25, whether it's independent or big budget. One really cool thing that Tableau does is if you see days spent shooting over here, this was a calculated field. What Tableau does is it over here will show us exactly what the calculation was for that field over here. There are a lot of these little things that are designed to help you out in Tableau. This is the calculated field window is easily one of the best ones. And you can press describe and it'll give you a little bit more information about this field. So you might be wondering what the ZN over here is. So let me show you exactly what it is. Let's see. So let's put waived fees in here. And I want to see the individual values. Application number. Let's see. There we go. So you'll see over here for our application number, this is where the waived fees are. You'll see that there's nothing there. I think for some of, I might be scrolling through it so fast, but there are, here we go. Yeah, here are some. You'll see that some of the applications have waived fees, some don't. So the reason we have that ZN in there, so ZN means 0 if null. So create calculated field, paste, and then what are we calling this? We're calling this fees per day. So what 0 if null means is if a null value appears, then replace it with a 0. And the reason that this is important is because a null value means that there is no value, no data inside that record. That's not the same thing as a 0. Null and 0 are not necessarily the same thing. Depending on your data set, they might be. Inside Tableau, they are not, though. So if for all of those fields, all those records that were null, total fees minus null will get you null, because you can't subtract a null from an actual number, which is why we need the Zn over here. The Zn will turn any nulls we have into zeros. So this is something that you need to watch out for whenever you're subtracting, adding, or performing any math in Tableau in a calculated field. If you try to perform math on a null field without turning the nulls into zeros, then you may get a bunch more nulls than you expect. Now, the reason I didn't wrap the total fees around this is because I know that there are no null values in there. But we could be safer and do the exact same thing here. All right. Yep, returns if not null. All right, so we have fees per day and days spent shooting. So now we know on a day-by-day basis how many fees a given movie was charged. So now we just need to turn this into a label. All right. So let's create one more calculated field. Analysis. Create calculated field, and we're going to call this one independent or big budget. And then copy this formula in there. Actually, this one, I'll type it out, and then you'll see why in a minute. So you'll see Tableau actually fills out stuff for me where it can. So I'm hitting tab basically in order to finish commands. Let's see, 250. There we go. All right, so what we just created is something called an if-then statement, and these are some very, very powerful statements. The basic structure of an if-then statement, if you look down here, if condition 1, then action 1. Otherwise, if condition 2, then action 2. Otherwise, action 3, end. So what this is basically saying is if the fees per day equals 25, then make this an independent film. Otherwise, if the fees per day is 250, then make this a big budget film. Otherwise, make this null. You might be wondering, why do we need this last else in here? This is just a good practice. You always should have an else in here just to take care of any instances that you might not, any conditions that you might not have taken care of up here. It's possible that our calculation outputs like, say, 35. And then Tableau needs to know what to do with that. For this exercise, we're just going to make it null. And you can see I wrapped the word independent and big budget inside these quotations. And this makes it a string. Basically, this is telling Tableau, output this as a string. So say independent, make the column say independent if the fees per day is 25, and make the column say big budget if the fees per day are 250. And you can see our calculation is valid. So we can hit OK. And you'll see Tableau intelligently put it over here because it's a dimension, because the values are either independent, big budget, or null. They're basically categories, and it's a string. Because again, it's the word independent, it's the words big budget, or it's a null. So what did we do? We just created 3 calculated fields, and these are, like I said earlier, some of the most powerful tools in Tableau, and they essentially allow you to add another column to your data set, which you can use to expand what your visualization actually shows. So earlier, we had no way of knowing whether a film was an independent film or a big budget film. Now we do, using data that was already available to us. And one thing to notice is that when you create a calculated field, you'll have this little equal sign show up next to these little signs over here. And that equal sign is basically telling you that you have a calculated field. So this is just the anatomy of the calculated field window, which I already went over. And there's a lot more to them than this. If you guys noticed, you would see that there are a bunch of different formulas inside here. I'd say some of the most interesting ones are probably regex ones, and regex, running, and window formulas. But those are definitely for a different day, and a lot of those are more advanced formulas that we won't really get into in this course. Let's see. All right, so using what you've learned, try and recreate the sheet shown below. So let me, in case you're just watching this video, let me expand this for you. There we go. So try and recreate this sheet below, and then I'll give you the answer in a minute. All right, so let me take a whack at it. Hopefully you paused the video and tried it out yourself. Oh, you know what? I need to see what's going on over here. So the easiest way to recreate this sheet is to just look at what's inside the columns and the rows, and the marks card if necessary, but it looks like nothing is there. So, let's see, this is application start date. Yep, as you can tell over here, application start date, independent or big budget. So that should say or big budget. Typo right there. All right. And then sum of the number of records. So let us take the application start date. Where are we? There we go. All right. Independent or big budget. And for those of you that didn't see what I just did, I clicked on this magnifying glass, and that shows this search bar that you can use to search for any field you want. And then the sum of the number of records. Take that, put it over here. And you'll see Tableau creates what I believe is the exact visualization you see here. There we go. Okay. Yep, looks about right. And then, oh, looks like we got to title it something. Oh, and we should probably title this too. Let's title this First Dashboard. I always switch my A's and my O's when typing in dashboard. And then this is independent. Movies by year. All right. Good stuff, good stuff. So what this visualization tells us is it tells us that there were no big budget movies until 2019. So that's obviously incorrect. What really happened was the fees changed between 2019 and 2018. But for the sake of our visualization, let's just say we only have them in 2019. All right, so now let's work on filtering our data. So one thing that you'll start to notice is that when you work with data, most of it that you're looking at is just not necessary. This goes back to that whole oil analogy I was using earlier, where you really need to refine your data and clean it up so that people can actually use it for something. This is one of those cases. For our purposes, there's no point in looking at anything before 2019. So let's get rid of all that data. There are a couple of ways you can activate or you can create a filter in Tableau. The easiest, in my opinion, when you have a visualization ready like this, just click on 2019 and click Keep Only. Again, if you didn't see, I'm just going to undo that. Click 2019, click Keep Only. And you'll see it only keeps that one. You can do the exact opposite too, where you can shift click. So if you hold down shift, click on 2018 and then click on 2013, you can exclude all those. And the other way, and this is actually the way I end up putting in my filters more often, you can hold down Control or Command if you're using a Mac like me, and then drag application date here. And let's see, you'll see that these are all the different ways you can look at a date value in Tableau. We only want to look at the year. So let's go to years. And we want to look at the discrete year. I only want 2019. So here is your normal filter view. This is probably the way you'll be looking at filters most often. But just know, any way it works. You'll start to realize in Tableau there are a million different ways to do almost everything. And I don't see that as confusing more than I see it as when you become proficient enough, then there are just a bunch of really fast ways to do things. It's great. All right. Okay. So now that we have, we've limited our data to only include 2019 data, let's try and make this graph a little bit more useful. Maybe it would be useful to see the distribution of these movies over months. Oh, whoops. I think I accidentally, see if I control click, then... So when you do that, make sure that you're actually holding down the Control or Command key. I must have let go at some point. Let's see. So right-click your date pill. And then you'll notice that over here, you have two different sections of what look like the same date values. Year, quarter, month, day. Year, quarter, month, day. I'll explain the difference between these in a moment. For now, just click on the top one. And you'll see our visualization. Oh, one second. Our visualization now shows the progression of permits over months up until October of 2019. So under Show Me, let's turn this into a line graph because we have date data and two different categories. A line graph might be very useful for us. So you might have noticed two things happened. When we switched it to a line graph, this month pill over here turned from a discrete to a continuous. So we have a continuous line graph over here. So you should have something that looks similar to this. And I clicked on this one over here, this line graph. There are a couple, but this is the one that I generally end up using. So this is something you need to be careful of when using dates and line graphs. So if you remember earlier, actually, let me go back. No, we'll use this. There are two sections of dates over here. You have your year, quarter, month, day, year, quarter, month, day. The top values over here, highlighted in blue in the PDF, those are discrete values, whereas these are continuous values. So I'll explain why that's important. So let's go ahead and do a little bit of experimentation. Let's go ahead and duplicate this sheet. So remember, you can either click this over here, or the way I learned to do it really was just right click. Whoops. Come on. Okay. Right click, duplicate. There we go. Right click your filter. Okay, yes. So right click your filter, edit the filter. So if you didn't see that, right click your filter, edit the filter, and then add in 1 year of data, 2018. So you might notice something. We now have 2 years of data, but I can't tell what year is what. So, and you might have noticed that the x-axis over here has not changed at all. Why is that? We added an entire extra year of data, and the x-axis is your date. So you would think that there would be something over here, right? Well, the reason that is because, and this is where it gets a little bit confusing, these values over here transform your dates into numbers, basically. Meaning that it is, when we have the month selected over here, it is adding up all of the Januaries together, all of the Februaries, all of the Marches, Mays. It'll be a bit more obvious if I switch this to discrete. There we go. So you'll see over here, we only have January, February, March, April, all the way until December, but no year. What Tableau is doing is that it is bucketing all of these individual months together and adding up all the values over the 2 years inside these months. So for example, May, this is 2018 and 2019 May. June, this is, what here? 2018 and 2019 June. In order to see it more clearly, I'm going to add 2017 and you'll see the same thing happen. It just increased the size of the values. If you notice this axis over here, it changed. If I take that out, you'll notice that basically Tableau just keeps stacking these values on top of each other. And the reason that is because it's treating these values as discrete values. And so it's just taking May and putting all the Mays together regardless of year. Now, this is a little bit confusing because you have discrete and continuous down here. What these represent is these just represent what the axis says. So is the axis going to use discrete values, which for dates is the named labels, January, February, March, April, May? Or is it going to use numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? And you can see it even has 0 and 13, even though there is no 0th or 13th month, assuming that there's a first month. In the data, because it's just treating this axis as numbers. So what you actually want to do is you want to switch to the continuous date over here. And you'll see Tableau now extends the calculation to show you December 2017 comes before December 2018, comes before December 2019. The PDF also explains this idea, but the basic idea is that, all right, there we go. You have your discrete dates over here, your continuous dates over here, and then this just refers to what the axis shows you. And this will group together all of your, every May and every June and every July, regardless of the year together. This one won't. This will treat May 2015 as different than May 2014, as different than May 2016. So with a line graph, you typically want to use this. There are situations in which you might want to use the discrete version, but for now, I'd just suggest using the continuous version. So go ahead and play around with this if you need to. Pause the video, play around with this, see if you can understand exactly what we did, what happened. Again, this is on your experimental sheet, so it doesn't really matter. So going back to the original sheet that we were using, these labels over here are not particularly helpful. Let's switch them to the discrete labels. And it's only 1 year of data, I think. Yes. There's only 1 year of data, so it's okay if we use the discrete values. Also, and weirdly, this is something I only learned, I think, maybe like 2 years into using Tableau or something. This menu over here will fit your sheet however you want it to fit. So standard is the normal way. It just does whatever it thinks is best. We're going to use fit entire view, and you'll see it extends to occupy the entire view, regardless of how big I make it. Congratulations, that's the end of section 2. So section 2 was, we covered fewer independent things, but we covered things of greater depth, which is why I split this off into a separate section, section 2. So as we can tell, it looks like there was a large spike in big budget movies produced in August, so I guess during the summer, versus earlier in the year, and obviously it dropped off again later in the year. Again, if you want to see a copy of what I made over here, feel free to download it at this link. There will be the same workbook, same as this one, over here. So in section 2, we went over calculated fields, date calculations, if-then statements. These things will save your life. They are tremendously powerful, but also don't be careful about making if-then statements that are like 20 lines long or something, or even 10 lines long. If you have too many if-then conditions, then that might be a sign that there might be a better way to handle this. We learned how to filter data, and then how to use line graphs, especially in relation to continuous versus discrete dates. So for this course, or for this section of the course, we will actually be using a different data set. We're going to be looking at some player stats from the English Premier League, and I think these stats are from I think FIFA 18 or FIFA 19 or something like that. So the EPL is the highest level of soccer or football for our international viewers, played in England, and is one of the most watched sports leagues in the world. And we'll be interested in plotting data on player salaries right now. So first of all, let's connect to our data. If you are coming in from section 2 of the course, you might have a screen like this. After you've saved this, which remember, if you have Tableau Desktop, you just go File, and then there should be a Save As button somewhere over here. If you're on Tableau Public, then you have to save it to the public gallery. And remember, anything you save to the public gallery is it's on a public cloud, so anyone can see it. So let's go ahead and open a new Tableau workbook. So under File, click on New, and it might take a second to open. There we go. So let's move this out of the way. All right, and you might see a screen like this or a screen like this. Either way, let's go ahead and connect to our new data. So it's going to be, let's see, another Microsoft Excel document. And this one is going to be player data. That's what we will be connecting to. All right, there we go. Here is our data source page. Remember that. So let us create our data source. So you might notice that the this Excel document is actually split into two parts. We have our English players on one sheet and our non-English players on another sheet. And we actually want to combine these two data sets. So if you take a look at them, so again, you can take a look at it by, whenever you see this icon means that this is how you look at the full data. So let's look at the English players data. You might notice, if you just look at all these columns over here, this looks like it's just some basic data on the players. And if we go to non-English players, then you'll see it is basically the same data. But these two sets of data are coming on two different sheets, so we probably need to stack them on top of each other in order to get a full data set. So we're going to be performing something called a union. Bring in the English player's data set first. Now right-click over here and click Convert to Union. There is more than one way to do this. This is probably just the easiest way to illustrate it. Non-English players, drag and drop here. So what Tableau will do right now is it will literally just stack these tables on top of each other. And we should have about 1,400 rows, I think. So you'll see if in Tableau over here, if you put in, so the default is 1,000 rows. If you put in something like 10,000, but there's only 1,400 rows, then it'll default to the maximum number of rows of 1,400. So what we did over here is we literally just stacked the two tables on top of each other. And this is something that in SQL we call a union. All right. Oh, and there's a potential bug over here in Tableau public. If the window, this window over here, if this doesn't show up, it might just be behind whatever your main Tableau window. So just go behind it in order to get to it. Looks like it didn't activate this time for me. But a union literally means that we're taking two tables and basically stacking them on top of each other. And we usually do this because oftentimes data sets are split up just to reduce the size of each individual data set. You'll find a lot of financial statements that are done in Excel are actually split up by quarter or month or year. So unioning data becomes something that is a SQL function that you will execute on regularly inside Tableau. And like everything else with Tableau, there's really no need to write any code or anything. Obviously, you can if you want to. You can just use the visual editor to accomplish the same result. So a union will take all of these column titles over here, these column headers over here, and it'll match them one for one based on the name of the column. Tableau doesn't care about the data type inside the columns. It just cares about the name. So as long as there's a style over here, color over here, model over here, it'll match all of those up. And anything that doesn't match, so for example, you'll notice on this example over here, the table on the left doesn't have a car column. What Tableau will do is it'll just put in null values for this part of the top part of the table over here. So all the columns will come through at the end. So let's go ahead and go to sheet 1. This is the data set we'll be using. So we connected to our data and then we constructed our data set over here by unioning all of our relevant data. So a good practice is to always inspect your data before you actually start visualizing it, just to make sure that everything is the way that you expect it to be. So looking over here, is there anything you notice that any column over here that you think probably should not be where it's currently classified as either a dimension or a measure or the data type that it's classified as? So if you pause the video and guessed height, then you'd be correct. So if we take a look at height over here, we can drag it into rows just to inspect it. You'll see that the values are coming in and they're written in as 5 foot 3 inches, 5 foot 4 inches, 6 foot 8 inches. This format is great for just labels, but it isn't good if we want to run any mathematical computations on it or if we want to compare heights across the data set. So let's see if we can fix this. Go back to your data source tab. So remember what we're doing right now is we want to edit this column over here. So we're going to go back to this data source and edit the data source. And then go all the way to the right in this data pane view over here. You'll see height over here. What we need to do is we need to split this up and then create a new column that just gives us the inches, inches that a player is. We could also do it in feet, but it's recommended that you just use the smallest dimension that you can. Sorry, the smallest unit of measure that you can. So with 6 feet 1 inch, you'll notice with all of these columns, all these rows, there is an apostrophe that we can use to separate this column, because what we'll need is we'll need a column with the feet and a column with the inches. that we can then add together. So the way we will split these columns in Tableau is to right-click over here and click on Custom Split. You can also just click on this regular split button, but Custom Split, I'll just walk you through the menu that we use over here. So the separator we're trying to use, we want to split this into one column that says 6 and one column that says 1. That way we can combine them together in a calculated field to calculate the total number of inches that a player is. So the separator we'll use is the apostrophe. So just type that in over there. And then we will split off all of the rows, or all of the columns. This is just something I like to use to make it much simpler, but you might sometimes want to only split off the first maybe like 3 or 4 columns. But let's just split off all of the columns and hit OK. And you'll notice that now 6'1" turns into 6 and 1. And Tableau will always just add this this suffix at the end of any columns that it splits off. Split 1, split 2, all the way till, you know, how many ever splits you end up having. So let's return to sheet 1. All right, so first thing we need to do is we want to turn this into a measure. That way we can compare heights, add them up together, take averages if we need to. So take height split 1, and like we did with wards in our previous data set, in our previous example, just drag it down to the measures area. You'll see that it's still a string, and you might even notice that there's a calculated field sign over here. That's because what Tableau actually does when it splits off columns is that it makes a calculated field that uses some regex in order to split the columns, make the columns. And that's just how Tableau handles splitting columns. It doesn't actually create a brand new column. It will create a calculated field. So let's turn this into a whole number. Both of these, number, whole number. So the way I did that was I just clicked on the data type and then turned it into a whole number. And speaking of data types, let's just go over what all the different data types we have can be. So in Tableau, you have 6 different data types, and they always appear to the left of your column names in your dimensions and measures menu bar. So a string is basically just a catch-all data type. It's any text really, and if Tableau can't figure out what your data type is, it basically almost always defaults to a string, because a string can hold almost any data inside it. At least any tabular data. Tabular data is just any data in the form of a table. Numerical data will have this hash symbol next to it, and that is any data that basically math can or let me rephrase that. Numerical data is actually any data that is a number. So, for example, a zip code or a postal code might might show up as a numerical data type. Oh, and the reason that I say math over here is because whenever I create visualizations and whenever I work with Tableau, I generally like to only classify things as numeric if I'm going to perform math on them. Otherwise, I'll classify it as a string, just to make things very clear. Date data is, well, we could have an entire course really on just that. There's a link over here you can click on to go see more about date data. But basically, and there is none on this data set, but date data is basically, all right, let's go back here. It is any data in a date format, and this is actually a lot harder to parse out than you would think it is. Tableau has a really cool system in its backend to actually parse out date data from a bunch of different formats that are out there. But for the sake of this course, most data you encounter will be parsed out the correct way. Date time has this little clock next to it, and basically it just means that a time is included as well. I generally try and avoid using date times when I can. Most data sets I personally work with, there is no need to go to the time level of granularity. And if a data set has a date time, if I can convert it to just a regular date, so just a calendar date, I'll do that just because it's a lot easier to work with. Boolean data is really interesting. So this is true-false data. So basically, if something is a Boolean, it can either be true or false, or like every data, it can be null also. So a lot of very well constructed data sets in Tableau. So if you have like a group of Tableau users, experienced Tableau users in your company, if they construct data sets, really well constructed data sets will usually have a Boolean value for common filters that people put in, such as current fiscal year versus prior fiscal year. So there might be a value over here that says TF current fiscal year. And basically you would just drag it into filters and click on true. And that would filter out your table to only include values for the current fiscal year. So in the future, this might be something that you'll end up using more. I don't use it that much unless I'm constructing a data set that is supposed to be used by the entire company. Geospatial data, again, this is something else that basically an entire course could be taught on. This is just any data in the form of place names, postal codes, states, countries, cities, or what we call geospatial objects, which we'll go over in more detail later. This is very interesting data, and a lot of really cool stuff can be done with it, but it's also very difficult to work with. So we won't spend too much time in this course talking about geospatial data, but those are your 6 basic data types. All right, so let's manipulate our data. So we want to calculate the height of different players, and we want that in one column. That way we can easily add that to our visualizations. So let's create a calculated field. So if you remember how to do that, click on Analysis and Create Calculated Field. Another way to do that, and the way that I actually end up using more often, is to right-click whatever field I'm going to use in my calculated field, and just click on Create Calculated Field, and Tableau automatically adds this field in here for me. So those are, like many things in Tableau, there's more than one way to do it. So let us name this height parentheses inches. And we are going to take the height in feet. So height in feet, which is height split 1, if you remember. Multiply that by 12 because there's 12 feet in an inch. Sorry, 12 inches in a feet. And then add that to height split 2. And that should be our calculated field right there. So that is so though that is basically, this is a sum of all the, so if you were to stack all of the players on top of each other, they would be this many inches tall in total. All right. So another thing that you might find interesting is that sometimes data that we bring in isn't encoded in a way that makes sense in a visualization. One great example of that is this column over here called Scale Moves, which you can right-click and then click on Aliases, and you'll notice that it just lists numbers 1 through 5 with a null. So this is actually a code that is used in FIFA, the game. And basically, we want to alias these to make these more useful to for an end user. So the thing is, what is an alias? An alias is basically just a fake name for something. So while the real value will still be 1, if we change the alias to, for example, weak skill, then when we bring this in here, the value will still be 1, but it'll just show weak skill on any visualization. So this is just a very useful way to clean up your data and make it much easier for people to understand what you're plotting. Below average. So just copy these labels over here. 3 should be average skill. And then high skill. All right. Click OK. And then so now you'll notice that all of these change so that although the base value is still 5, 3, or wait, sorry, 5, 1, 2, 3, 4, and null is null. The label has changed so that it is more informative to any user that uses your data. So aliases are incredibly useful, and definitely something I recommend using whenever you can in the future. All right, so let's drag this new column that we created, height inches, into our columns. And let's drag weight into rows. Where are we? Weight. Drag that into rows. And then you might have noticed that this whenever you drag in a measure, let me bring in a dimension just to compare. You might notice whenever you bring in a measure, it's not just the column name that's listed up here. It's also this thing over here. It usually says sum. Sum is the default that it shows. But if you bring in a dimension, it just shows the dimension. The reason for that is that this is what you call an aggregation. Again, if you've used Microsoft Excel, this might be familiar to you if you've used pivot tables especially. And an aggregation basically tells Tableau how to group together different measures. So let's change the aggregation of these from sums to averages. So you do that by right-clicking the measure, going down to measure parentheses sum, and then clicking on average. And we do the same over here. Right-click, measure sum, average. And you might notice that the values on these x-axes, the x and y-axes changed. So it used to be 110K and 240K. And what this was this was literally Tableau adding up every single player's height and every single player's weight to get these two numbers, which is not what we're going for. But now I can tell you the average player is 71 inches tall and 166 pounds. So how can we best explain aggregation? So there's a small visual I put over here. And basically, say your data looks like this. You have everything, you have your years, you have your months, your sales, and your revenue. Now say you want to look at the data at the year level. Well, what can you do? What you'll do is you'll take out this month column. It's unnecessary information. But then what do you do with the sales column? Well, you'll need to combine this, combine your measures somehow, basically. So the way we combine measures is what we call an aggregation. These are levels of aggregation. So we're grouping at the year level and aggregating our data through a sum. So for example, for sales, if we are looking at everything at a year level, we have 2020 over here and 2021 over here. We need to add up our sales. 22, so 10 plus 12 is 22, and then 14 plus 13 is 27. And we'll do the same thing for our revenue. 100 plus 120 is 220. 150 plus 120 is 270. That's just one way to aggregate our data. You can use an average for an aggregation as well, where what I'm showing you over here is that this is a sum aggregation versus an average aggregation. You can do maxes or mins, where basically Tableau will just look for the maximum value within that group. So the group we're defining as the year over here. What is the maximum value for revenue in 2020? It is $120, you see over here. What is the minimum value in sales? That's $10. Or sorry, 10 units. These are units, not dollars. Count and count D are interesting. What count does is count will give you the number of values in a certain group. So for example, in each of these groups, there are, for 2020 and 2021, there are 2 values apiece. Count D will give you the count of distinct values. So for example, I think the example I used was over here. Sorry. Yes, we're looking at the month now. So what we're doing is that we're taking the count of the month. There are 2 months in each of these years. And in this data, basically, they're just we split January into 2 different columns. But the count D for 2021 is only 1 because there's only 1 distinct month in 2021. So that's count and count D. So I usually, whenever I explain this to people, I'll say that I'm either counting or count D-ing the data. ATTR, or attribute, is a very special aggregation function. Basically what it does is it will look, if for a given measure or a given value, or for a given measure in your column, if there's only 1 value there, then it'll output that value. Otherwise, it'll output a star, When you start using more complicated calculated fields, this will become very important and very useful, because in Tableau, you can't combine aggregate functions and non-aggregate functions. And as you start to work with Tableau a little bit more, you'll learn what that actually means. But as an example, if we are trying to aggregate the months at the year level, then you'll see that the attribute aggregation can't output anything for 2020 because there's no single value over here. We have January, we have February. It doesn't know what to put here, so it just puts a star. But in 2021, we only have January. So because of that, it's able to give us the attribute of January. So this is something that you'll encounter as you use more advanced functions, but for now, it's not particularly useful. All right, let's go back to our data. And let's create a scatter plot. So drag position into colors on the marks card. So where is position? There we go. So we need to drag position into colors on the marks card. And then let's just add all members. So you'll see we get a scatter plot that looks like this. Tableau by default starts off at 0. But for this function, that's not particularly useful. As you can see, we can barely see anything up here. All the values are grouped over here. Why is that? Well, that's because there's probably no player who's only 10 inches tall, and there are no players who are only 20 pounds large. And because of that, basically this entire section of the graph over here, this area I'm outlining, or let's see, over here, this is not particularly useful information for us because there is going to be no player that is this small. And there's going to be no way that the average for the player's weights could be dragged down to this level, just because this would be way too small for a player. So let's go ahead and change our axes. So the way you edit your axes in Tableau is you literally just click on them, right click, and then click Edit Axis. So we clicked on our y-axis, and we right-clicked it, and we clicked on Edit Axis. Here is our general information. Let us just uncheck this Include 0 checkbox. And you'll see what happens. Tableau just starts it off near the lowest value. It starts it off a little bit above that. That way you don't have a value on the edge of your graph, which is something I highly recommend avoiding. Don't have values on the edges of your graph because it can just make things feel claustrophobic. Over here is also where you can change the range of the axes in general. So this is the y-axis, remember, and even the title. So we can change this to say, to not contract it, average weight. And if I click on X, you'll see it shows up right there. Let's do the same thing to our x-axis. And you'll see we have a much more useful graph now. Now, the reason we're able to do this is because if you're talking about FIFA players, you're talking about people who are relatively similar in size and relatively similar in weight versus, for example, if you were talking about the entire population of England, you would include like babies and kids and stuff like that, and your graph would probably benefit from having a 0 value on the axes. But because we're talking about people who are relatively similar in their physical build, at least in comparison to the rest of the population, it makes more sense to zoom in to where the change actually exists. And this is a good practice to have. You want to be able to actually show a differentiation in values on your graphs. Some people will say that axes have to start at 0. That's just not true. Although it all comes down to context. One of the most obvious examples of abusing axes in order to prove a point is this graph over here. So this graph is maybe like 10, 15 years old now. But it basically, what they did is that they started the axes off at 34 over here and then went all the way up to 42. And the change in what we're talking about, the top tax rate over here, looks monumental when it's really just a 4% change. Not to say that that's small, but the point is it's made to look a lot larger than it actually is. And this graph actually misses out on a lot of context from previous administrations and everything, where the top tax rate was all the way up to I think 50% at one point in time. On top of that, the axis was moved on to the right side of the screen, where it's not at all obvious to a normal English reading audience, where in English we read left to right, that what scale this graph is even on. But another example, and this is where a lot of visualization really comes down to just understanding your audience, is this graph over here. This graph starts off at 0 and then goes up to 5. But it's not particularly useful because I can barely tell what's going on over here. This is an example of where you might want to show or you might want to take out the 0 and start off at a higher value. That way people can actually tell that there is a change at all. And what I find is that usually when you're measuring your metrics for your business, or whatever you use Tableau and visualization tools for, there are what we call bounds. Basically, there is a minimum amount that a certain metric will go down to reasonably, and a maximum amount that a metric can go up to reasonably. And I usually set my axes to be a little bit below and above that. And this is an excellent example of that. Again, like we said earlier, there's not going to be a player who's 0 inches tall. There's not going to be a player who weighs 10 pounds. So because of that, because when you show someone the data, you'll be explaining that to them. You'll be showing them, hey, look, this is the average weight and average height for FIFA players. It's fairly obvious that they're going to be distributed in a certain small part of the graph. So as long as you set the context, then you can make the axes whatever you want. But do be careful with how you do it, because it can mislead people who don't know how to read or don't know how to interpret your graphs. All right, so another thing is while we're talking about moving the view of the graph and manipulating the view of the graph, a couple of things. If you want to pan around this graph, basically drag it around, hold down the Shift key and then just drag, and you'll be able to move this graph around as you please. If you want to return to your old view, then you can always just click undo. Or you can click on this pin over here. So this pin basically means pin the graph to that view versus automatically try and fit everything inside the graph. If you want to zoom in and out, then hold down the Control key if you're on Windows, or Command key if you're on Mac, and just scroll. So you can see this is how we can shrink or expand our data. And then click on that to return to the default view. And then obviously you can click on any axis and just edit the axes. Oh, and let's rename this sheet. Average measurements by position. All right, grouping our data. So sometimes the level of detail that we have is too granular, and in these situations, grouping our data might be helpful. So if you notice over here, for our positions, we have like 24, I believe, 24 values over here. Yes, 24 marks. There we go. So we have 24 values over here, and that is not particularly useful for our viewer. Maybe we can reduce the number of positions over here by grouping them into groups that make logical sense. So if you want to make groups with your data, just right-click on whatever column you want to make groups out of, and click Create Group. And you'll see Tableau brings up every single position over here, and then now we can start grouping them the way we want to. So we're actually going to be grouping them based on what type of position they are, like midfielders, defensives, or forwards. And this is where I always say knowing your data is key to making any data visualization. If you don't know your data, then visualizing the data is going to be much more difficult. And I can say that I've probably saved more time than I've lost by taking the time to ask people different questions about the data, try and understand it before I try and make a visualization versus trying to make a visualization on data I don't fully understand. So let's start grouping our data. The way I like to do it is I like to hold down the Control key if I'm on Windows, or Command key if I'm on Mac, and just select what I need. Another easier way to do it, if you don't want to just hold down the key, is to just select the first member you want to put in your group, which is CAM over here. Click group. And then let's name this group midfielders. And just drag in any value you want into that group. So CM, we need LCM, LDM, LM, LW, RCM, RDM, RM, RW. All right, so there are our midfielders. Let's get our defensive positions. So these are the basic ways you can split up the positions. And grouping your data is incredibly helpful because contrary to popular belief, you usually don't want to just put a bunch of data in front of people. You want to limit it to what will give them the most insights with the least amount of mental effort. That's generally how I like to view my visualizations. Of course, depending on who you're presenting the data to, you might want to show them more or less. Generally, the higher up you go, the more or the less granular your data gets. The higher up you go, the corporate food chain. All right, forwards. Okay, cool. And then just hit OK. And then let's zoom out over here. And let's go back to our data source. There we go. Oh, sorry, before we do that, let me show you what we just did actually. So you can take this new group over here, which what Tableau did is it basically created a new column for our positions that grouped everything together the way we wanted it to. Take that and replace this position pill over here. And you'll see, on average, it seems that defensive positions are the heaviest guys. Makes sense. Forwards are are medium in weight and height. And midfielders are the smallest. Now, obviously, take a look at your axis and see how much of a difference that actually makes. We're talking like a difference of 3 inches and 13 pounds. The 13 pounds might be substantial. The 3 inches may or may not be. But you can see we were able to clean up our visualization substantially. And even the legend over here is a lot cleaner and easier to look at now. So let's go back to our data source. So we're actually missing quite a bit of data. And what you'll notice is that, I forgot who it was. I think it was IBM that did a survey of a bunch of data scientists. And they found out that data scientists tend to spend about 70 to 80% of their time just gathering and cleaning data. If you work with data, this is probably where you're going to spend a lot of your time, which is why it's very important to get these skills down pat. And sometimes your data comes in a unfortunate format or a format that's not easy to use, like a PDF. And PDFs, if anyone's ever tried using them to get data from them, they can be very hard to get data from. But Tableau can make it quite easy for us through some technology they have in the background that's supposed to help you extract data from PDFs. So let us add a connection. We're going to connect to a PDF. So we have we're going to modify this data source over here to add more relevant data. We're going to be performing a join, but first let's bring in the data we want to join. So under connections, click add, and let us add a PDF. And then we have data to join.pdf, and let's bring in all of the pages. So this might take a second. Awesome. Okay, so if we want to join this data over here, then we just need to drag this to the right-hand side of our data, of our current data. You might notice that we now have two different connections. We have a blue one and an orange one. And we're going to combine these connections and create our data source over here. So it shows up as just one unified data source in our workspace. So this is actually another way to union your data. So click on the first page, then hold down Shift, click on the last page, and then drag and drop. And you'll see Tableau unioned all of your PDF data and then brought it in for a join. So in the Venn diagram over here, click on the Venn diagram and then click on left. We're going to be doing a left join. Then you can exit out and go back to the sheet that we were working on. So what we just did is we joined on our data. So like earlier we discussed when we needed more data, one way to get more was to union it, basically stacking tables on top of each other. A join is another way to add more data to your data set. So while a union will add more rows to your data, a join is usually used when you want to add more columns to your data. Now, you can add more rows using a join too, but it's a way to add your data, add more columns to your data. That's usually how we look at it. We did what was called a left join. If you go back to the data source tab, you'll see that it's covering, we're using the left side of the Venn diagram. That's a left join versus, say, an inner join, a right join, or a full outer join. So what exactly is a join? Well, in a join, we have two tables that we need to combine, right? We have something called our left table and our right table. We want to join them on columns. So what we do is we define a column to match it on, in this case ID, and then we match it one for one. So let's take a look at the types of joins we can do. Like I said earlier, we can do inner, left, right, and full joins. And you'll mostly be sticking to left and inner joins. Like you can do a right join, but usually people will just do a left, we'll just switch the order of the data sources and do a left join. So an inner join, what is that? So an inner join basically takes the column you're matching on, or you can also match on multiple columns, but for the sake of this explanation, we'll just stick with the one column, and it'll find exact matches. So for example, in this, with these two data sets, with your left join over here and your right join over here, there's only one column that matches between the two, the one with ID number 1. So our result table ends up looking like this, where you only have one row of data, and then this top row is the header row. If you were to do a left join is the same as an inner join, but it keeps all of the data from the left-hand table. So while we have the same match over here on ID number 1, we also have to add in ID number 3 because all the data from the left-hand table has to stay. And where we don't have data from the right table because there is no ID 3 here, we just have 2 nulls. Now note, when you, obviously if you have 2 columns that are named the same, which you're matching, one of them has to be renamed. Usually the right one is the one that's renamed. A right join is just the exact opposite of a left join, where you you do an inner join, and then you also add in all the columns from the right-hand side. So if you'll notice over here, there's a reason we use Venn diagrams to illustrate this. An inner join basically keeps all the intersecting values, or all the values that match on both tables. A left join will keep the values that match on all tables, between both tables, plus all values from the left-hand table. And a right join just does the opposite. And then we have what's called a full outer join, or just a full join, which will basically just stick the 2 tables next to each other, match what it can, but keep everything. So there's a common gotcha that you can encounter in a join. What happens when you're doing a join? Let's say we do an inner join, and on your right-hand table, there are 2 ID 1s. Well, what will happen is that ID 1 on the left table will match to every ID 1 on the right-hand table. So you'll see we actually duplicated the values over here. This blue and this 30x under color and model. We actually duplicated it for a row. So that's a common join gotcha. I call it a gotcha because it's not an error necessarily. I've used joins before because I intend to duplicate rows. And it is a function that can be used to your advantage if you need to, for example, match one value to like 13 different values on a different table. You can do a join, and it wouldn't be considered an error. So this is something to watch out for. A well-designed table will have a key value that you can usually join to, and a key value by definition has to be unique. So if you have a key column and a foreign key column in a table, that's usually what you'll be joining on. So what we did over here was we brought in data from our PDF and we joined it on the ID column using a left join because we want to make sure we keep all of this data even if there isn't necessarily a match over here. We need to keep all of our player data. And you'll see Tableau very helpfully highlights our columns from our right table with an orange bar over here versus the blue that's the default when you're looking at the columns from the left-hand table. So you'll see we're bringing in a lot of player wage data. So their value, their wage, release clause, all that stuff. And let's go back to our average measurements by position table. So one thing you might have noticed was that the value, wage, and release clause, they are being brought in as strings. This is because they're being brought in through a PDF. A lot of the PDF values won't default to the string value that you would expect them to be. So let's correct these. Remember, we just drag them down here because these should be measures. And we will change these to, let's see, decimals or to, oh, actually not even that. What we actually want to do is we want to change these to euro amounts. So this data set is supposed to be in euros. So, excuse me. This data set is supposed to be in euros. So we will go to default properties. So right click any of them, default properties. Oh, my bad. You first need to convert it to a number. So let's convert these to numbers first. I was wondering. Now if you go to default properties, you'll see number format. So make sure you convert these to numbers first. And we want the currency standard will just give you the standard currency in the United States, or just whatever your computer's configured to, I guess. I'm in the US, but we are looking at euro data, so I need to replace this with a euro value. Don't worry about this if you, don't worry about this if it's too much work. But if you go to the next page on the PDF, you can copy and paste that value here. This is just to show international users or people that work on teams across the globe that you can easily change the currency value in Tableau. So let's do that for our value. Remember, default property. So right click, default property, number format, currency custom, and then we'll change the prefix. And then let's do the same for wage. All right. And then let's see if you can recreate this visualization right here. So pause the video. Let me expand this and try and, recreate. Okay. Try and recreate this visualization right here. All right, so let us see if we can recreate the visualization. So what we're trying to do here is we're trying to see how much each club spends on their players by position group. Those these position groups that we made over here. So let's create a new sheet, and let us bring in the value. And then let's see. Let us bring in the club. And we're going to put that on our rows. And we need to split up each of these bars into the different positions that we have. So we'll put the position group into the marks card color. The colors might be a bit different than what we had earlier. So, this is why. So when there's an instruction that I skipped, under position group, you want to right click, edit the group, and you want to include other. And then these colors are still different. So the way we change that is by going to this color card over here, edit colors, and then I believe defensive positions should be blue. So click on defensive positions, click on the blue. Forward should be orange. So forwards, click on forwards, click on orange, and midfielders are red, and other is gray. There we go. And I like using these colors by default because they all contrast with each other while at the same time not conflicting with each other. So they contrast and don't conflict. That's the best way to put it. And these are the default colors Tableau will put in automatically. So then let's sort this by clicking on this sort button up here in descending order. So you might notice this still looks a little bit different from the graph we have over here. Do you know why? Well, you might have noticed that the graph over here, the level of the method of aggregation of our value is a sum. Over here, Tableau used count D, which means count distinct. By default, because this was converted from a string, from a PDF. So you can right click that, go to measure, count distinct, and then change that to sum. And we might have to sort again. Yep, and this graph is the same as this one, just it's been shrunk down a little bit. Now, in order to prevent us from always having to change that aggregation for value, because we're never going to want to see the count D, you can right-click the value. You can right-click the column, go to default properties, aggregation, and then make sum the default aggregation. Now we can also do that by we can also do that for release clause and wage. These are all numerical values that we're probably going to want to sum before anything else. But if you don't want to change it over here, you can always change it over here. Now, whenever you change the default properties over here, be careful. It can be easy to get into the habit of changing the default properties whenever you want to just make a minor change on the graph itself. So only change these default properties for things that you want to reflect across your visualization. Otherwise, you'll be making a bunch of one-off changes, or you'll make a permanent change to what might just be a one-off change. A good example of that would be these decimal places over here. So there's no point in having the decimal place over here. So there's two things I could do. I could go to value, and I could right click and go to default properties, number format, and I could change the decimal places to be 0. And that would change it down there too. So if you look over there, oh, I must have only made 1. So you can do that, right? But that'll change it across all visualizations for your entire workbook when you might not necessarily want to do that. A better way would just be to change this one axis over here by right-clicking, edit axis. Actually, we want to format the axis. Right-click, format, and then under numbers, change it over here. So this isn't changing the default value. This is just changing that one axis. And then we have to make sure we use a euro over here too. So that's just some professional advice. Make sure that you if you're making a one-off change for just one graph, like I want Tableau to keep the decimal values for the value column, but I don't want them over here. Just change them in the one graph you need to. Don't change the default properties unless you need to. All right. Let's name this visualization player value by club. So the marks card is something that we just use, and it is one of the most useful parts of Tableau. You'll hear me say that a lot. This course is supposed to really just give you a quick and dirty guide to the most useful parts of Tableau. So the marks card is basically how you edit what is shown over here after you've already put your data in over here. So you define where the data will actually show up. So what's a column and what's a row up here. And then you will put everything into the marks card over here. And you will edit how it's shown in the marks card over here. So as you could see, that's how we edited the color. We clicked on the color and then edit colors. And when we wanted to actually show the different bars over here in different colors, we took the column that we want to split everything up on and then drag that into color. There are a number of other changes you can do over here. The one that we'll be working on next is how to label the ends of columns in your bar chart when you have multiple groups in a column. Another thing is you can also change the type of graph that shows up over here. Although I personally use the Show Me menu because it will show you the different types of visualizations you can use with the data you currently have on your view. So let's say we want to add labels to this graph. You would think the most obvious way to do that would be just to drag value, because we want to label the values, to this label over here, right? So let's try that. Go to value, under your measures, drag and drop. So you'll see Tableau is only putting the values on certain marks over here. Remember, a mark is basically an individual group of rows shown in Tableau. So for example, this is one group of rows. This is these are all midfielders at Liverpool. So this represents all midfielders at Liverpool. So this represents all the rows of data where that condition is true, and we call that a mark. So you notice that we put the label in here, but these labels are not necessarily very helpful. And the reason for that is that Tableau doesn't want to create a big mess and have labels overlap each other. You can click on label over here and under options, click allow labels to overlap other marks. And you'll see it's just a complete mess. So that's not very helpful to us right now. And you'll find that this is a problem you encounter regularly where you might want to label everything, but you just don't have the room to do so. So let's see if we can put a label mark at the end of our graph. The reason we can't do that at the moment is because it is trying to label at the smallest grouping we have, which is the position group. But we want it to label the ends of these graphs. So let's try something out. Click on the Analytics tab up here on the upper left corner. The Analytics tab has a lot of useful things to analyze your data after you've actually visualized it. Double click on Reference Line down here under Custom. And then this menu pops up. You can drag it to the side to see what the actual changes are because the changes are live. Let's click on the per cell option because right now what happens is it's averaging everything across this pane over here, but we want it to do on a per cell basis. And let's see, we want it to show the total sum, not the average. And let's see, let's make the label, instead of saying computation just means like, what am I doing here? I'm just summing it. Let's make it say value. There we go. So that's actually what we want. and then remove value from the marks card. So now you'll see this label is a lot more helpful. It just tells you the total that the total value of all every team's players. Obviously, Manchester City has the highest value players. Now you might have noticed something called reference. Let's see. If you want to edit a reference line, you just have to click on it. So I can click on this label and click format, click edit. You might have noticed something called pane over here, per pane, and entire table. So the scope basically just defines where the reference line is going to be. When I did entire table, it's adding up every single player on every single team, all of their values all together. Per pane right now does the same thing because there's only one pane of data. Let me show you what a pane actually is. So you don't have to follow along here. This is just to demonstrate something. Let's see. So what is a value I can use? You know what? Actually, I can do this. Position group. Okay. So you'll notice that the data, now that we have two different dimensions inside our rows, is divided into what we would call a pane. So this is one pane, this is another pane, and then here's your data. So now, if I go over here and I edit this, and I click on per pane, then you'll see what Tableau does is that it's calculating the total value of all the players per pane, which is the same value that we had earlier. So this is what a pane is. A pane is basically when you, like a window pane, whenever you have multiple dimensions, you'll create a pane basically. So that's not what we want right now. That was just to demonstrate what a pane is. Okay, perfect. This is what you should have. Yes, so here's what we end up with. And so this visualization is actually a very solid one. This communicates exactly what we need. But it shows, and it's great at communicating the value of players per team in comparison to other teams. But what about the value per team in comparison to the whole, in comparison to the entire league? Well, this is where an average line might be useful. So under analytics, you can drag average line into the table section over here. So you'll see what happened is when I click and drag average line, it'll ask me where do I want to add the line. Now in this table, remember a table and a pane are the same thing, but we want it across the table. Then go down here to where your average line is, click on it, click on edit, and then change this to custom under label. Change this to custom. And let's make it, I believe we want it to be, yes, computation value. So computation is what we're doing. And then let's add a colon over here and a space. And then let's add value over here. So you'll see what it did is it changed the old label from just saying average to now say average and then give you the value. And then this looks a little bit cramped, but when if I expand the amount of space that it has, then you'll see it's a much better visualization. So now we have a full-featured visualization that communicates to your users a lot of useful information. With just a couple of clicks, we were able to show users this is how much each player's, this is the value of the players per team compared to the average and compared to all the other teams. And you can see where teams disproportionately spend their money on. It's midfielders for a lot of teams. Then they spend the least amount of money on forwards. So let's go ahead and add a little bit more data. Click on the Connect menu icon. That's this icon on the upper left corner, up here. And let's bring in a spatial file. So this is a special type of data that is you can't just use in any piece of software. We're going to be using something called a KML file. This is a Google Earth file. It's open source, and Google actually submitted this data format because I think they're the ones that created it, or they like acquired it or something, to the consortium that is in charge of standardizing these geospatial data formats. So a .kml format is a format that if you work with geospatial data, you'll probably encounter quite a bit. So we want to bring in the data to blend data set, and then under name over here, what this data set includes, that this includes the point, the geometric point, a geographical point of every club's football stadium. So let's right click name and rename this value to club. Is it club or clubs? It's just club. Okay, cool. CLUB. There we go. And we can rename description to stadium. Okay, come on. All right, good stuff. Let's create a new sheet. And you can see now we have two different data sources over here. We have this data source, the one we were just working with, English Players Plus. And this is, if we go back to this data source window, so click on that and then go back to the data source window, you'll see this is a data source we've constructed by unioning all the English players and non-English player data, and then joining that to a union of all the, I believe it was, financial data for the players from that PDF we imported. And this is considered one data source. So this one data source is created from two different connections. And now we've brought in a new data source, data to blend, which is a spatial file. All right, so it looks like we just imported, our spatial files. And the thing about spatial files is that they are a very special data type that you can derive a lot of information from. They can be a little bit complicated to work with and even harder to create depending on your expertise with GIS data. But spatial files basically have three basic geospatial data types. You have your points, your lines, your polygons, and you can use them to create visualizations that would otherwise be very difficult to create. So now we're going to be talking about a concept called the data blend. A data blend is a concept that we use in Tableau that is similar to a left join, and I'll show you exactly what I mean in a second. So we have the data, we have our data set English players, which has all of our player data, and then we have data to blend, which has all of the data on the locations of the stadiums for different players. For different teams, sorry. So under the Data menu tab, click on Edit Blend Relationships. And you'll notice Tableau will split the blend relationship into a primary data source and a secondary data source, and we have clubs match up to clubs. What is a blend? So a blend, like a join, or a union, quite frankly, is designed to help you combine multiple data sets. But the big difference is, although a blend is like a left-hand join, a left join, it doesn't, it aggregates everything after, it aggregates everything first and then joins the data instead of joining it row by row. So whereas a left join, what it does is, if we go back over here, it's taking every single row and it's joining it, joining the English players data over here with our PDF data over here on a row by row basis. So like we showed earlier, it looks at, I believe, the ID column and then joins everything row by row. A blend, what it will do is it will look at what you have on your visualization, aggregate all of your data to that level, and then try and do a left-hand join. So it's a little bit different. So you'll see over here, this is an example of a left-hand join where we create some duplicates because we have a ID of 1 over here and we have 2 1s over here, right? So we create the duplicate, blue 30x, blue 30x. In the data blend, we won't have this duplicate because it's going to aggregate all this data over here before it allows for the join to happen. Now, what happens when you try and aggregate categorical data like this, a dimension with 2 different values? Well, you'll get a star, like we had earlier with the attribute function, because it doesn't know how to combine these 2 numbers, these 2 strings. There really is no way to do that. If it was a measure, then you could aggregate them in some way, as in you could sum them or average them or count them, but with a dimension, there is no way to do that. So in Tableau, you'll notice that blend is defined by these chains over here. So if you go back to your Tableau workbook, you go to Data, Edit Blend Relationships. We've related the column club to the column club. From both tables. That's actually why we renamed the column in when we were bringing in the data to blend. We renamed it that way we could Tableau would automatically combine these 2 columns. It would already associate these 2 columns. And what we can do is we can double click. So go to data to blend, and you'll see when I click through these things, I get the columns from the 2 different data sets because these are 2 different data sets. So go to data to blend on a new sheet, double click geometry. And you'll see what it does is it plots all of the different stadiums across the UK. Under show me, make sure that the symbol map over here is selected. And then drag clubs into the details section. So now go to the English Players Plus data set. You'll see that Tableau has automatically linked this column for us, where if I click on this, then these 2 data sets over here are no longer linked. But if I click on this, they're linked. And I can now use data from this data set, and it will combine them on the club field after it aggregates to the level of detail available on this visualization. So let us take value. Let's see. There we go. And put that under size. And you'll see over here that we have a blue circle check mark over here and an orange one over here. Blue signifies that data to blend is the primary data source on this visualization. And orange signifies that this is a secondary data source on this visualization. You can have multiple secondary data sources, but only one primary data source. Let's see. So what you can do is you can go to size over here, and then you can edit the size to something that, maybe makes it easier to see. What I also like to do is I like to go to color, and I typically use 75% opacity, and then I will make the border black, and you'll see that pops a little bit more than what we had earlier. But basically, because we were able to use a blend, we were able to combine these 2 data sources. Now, could we have joined these 2 data sources? Yes, we could have. This is just to illustrate what a blend does, because you can't join all data sources. If you ever use Tableau server data, that data cannot be joined to other data sources. You have to blend it. And sometimes a blend just makes more sense. Usually a blend makes more sense if you're just trying to add some descriptive columns to a data set, which in this case, we're just trying to add where is the stadium located. So now we're going to work with something called parameters. If you remember, I believe it was section 2. I believe it was section 2 where I talked about how we were going to discuss parameters and parameter actions later. A parameter basically is a constant that you can insert almost anywhere in Tableau, and you can use it to edit, and you can edit it as you need to change, say, a filter or a calculated field to, or dynamically. So let's go ahead and see what this actually does. Let's go ahead and drag club to filters. So club from the English Players Plus dataset. Go to the top tab over here. So you have general wildcard condition top. These are just different ways to filter your data. Let's filter it by a field. I want the top X by age, or sorry, by value sum. So this X value over here, you can make it whatever you want. I can make it, 12, I can make it 2, I can make it 4, or I can create a parameter and make it dynamic. So let's change the parameter's name to top teams by player value. And then change allowable values to list. So allowable values will basically say what values can you are we allowed to have in this for this parameter. The value is the actual constant that will be that will replace whatever value you want it to replace, and the display as will be what it's displayed as. So let's see. I want 1, and I want this to be top team. I want, let's see, 5, 10, and 20. So now what we've done is we've created a parameter, which is a constant that we can change whenever we want. And I've said, okay, the parameter named top teams by player value can have the values 1, 5, 10, and 20. But I want them to be displayed as, so this is kind of like an alias, top team, top 5 teams, top 10 teams, top 20 teams. And what's going to happen is this 1, 5, 10, or 20 will replace this value over here. So for example, we are only going to show the top, say, one team, one club, by, when I change this, the value sum. So click on OK, and then change this to value, the column value, make this a sum, and hit OK. So you'll see only one value is shown over here. This is Manchester City, the team, the club with the highest combined value of players. Now, I can dynamically change my parameter to show the top 5 teams, the top 10 teams, and the top 20 teams. And what Tableau is doing over here is that it's, when we go to say top 5, it's replacing the filter over here. It's telling the filter, hey, include only the top 5 teams by the value of the sum value of their players. This is just one use of a parameter. You could also use a parameter inside a calculated field. So for example, I could say, let's see, 3 plus, let's see, what's the parameter's name? It was what, top team? Yeah. And then this value would change depending on whatever the parameter was. So let's say parameter calculated field description. Parameter calculated field demonstration. And you don't need to do this. This is just to demonstrate what it does. Let me make this a dimension and then put that on our labels. You'll see it says 8 because the parameter's value is currently 5, and I told Tableau to calculate this field to be the value of 3 plus whatever the parameter is. Now, if I change this to 10, you'll see it's 13. If I change it to top team, it should be 4. So that is what a parameter can do. It is a constant that we can change whenever we want to. So let's get rid of this. Oh, and if you don't see this control over here, then you go all the way down here. You'll notice your parameter is now down here. Right-click the parameter. All right, right-click. Show parameter control. Make sure that's checked. If I uncheck it, you'll see the parameter goes away. This is a tremendous way to show stakeholders or to let stakeholders play around with different functions on your graph and maybe demonstrate the effect of a certain change that your team is experimenting on to your company's, to whatever system you're modeling. So parameters are constants that can be used all over Tableau. You can use them to dynamically change a calculation, to filter data by measures, and to allow an audience to define certain criteria when exploring your data. All right, now let's make what we call a choropleth map. For the longest time, I used to call these choropleth maps or something like that. But this is called a choropleth map. And then let's change this to top teams by player value map. And let's create a new sheet. All right, so nationality under English players, right click, geographic role, country/region. So what this is doing is this is telling Tableau to look at the nationality column, which if you want to see the values inside it, we can drag it to rows. You can see these are all countries. And we're telling Tableau to, instead of looking at it like a string, this is a country. So now double click nationality and you'll see it'll plot a map. So this is what we call a symbol map. Let's change it to a choropleth or a choropleth map. Show me choropleth. So now we see these are all the countries that the UK gets its players for the Premier League from. So let us see how what country sends the highest value of players. So under value, or drag value to color. Okay, good stuff. Make sure that the aggregation is at is a sum aggregation. So you might have noticed in a couple of our visualizations there is this unknown tag over here, and basically this is just saying that Tableau doesn't know what some of the values are. So we can click on that and click on edit locations. I'll be the first to tell you Tableau is not particularly smart when it comes to locating geographies and won't recognize a lot of stuff. A lot of stuff is just not coded in there. So let's correct what we can. Korea Republic is actually South Korea. And Macedonia, I believe that's just North Macedonia. But you'll see, for example, for the different countries within the United Kingdom, it doesn't know what to do with them. So for the different countries within the United Kingdom, it doesn't know what to do with them, so we will just leave them be. So like I was saying earlier, Tableau is very strict in how it recognizes geographic locations. So this is something that you'll find yourself doing quite often. You'll have to correct locations. If you want to hide this, just right-click and click Hide Indicator. So let's name this map, or this sheet, map of countries by player value. And then create a new sheet. And see if you can recreate the visualization below. So let me expand this. So pause the video and see if you can recreate this visualization right here. All right, we are back. So let me put this over here. Zoom in a little bit. All right, so what do we have? It looks like we have top 5 players by position. There we go. And let's see, we have player group, name, and some values. So let's put that over there, player group, and name. Where are we? So you'll see I just double clicked a bunch of things, and then this is the exact opposite of what I want. So I can click on this swap, what I call the switch axes button, and it switches axes. And let's see if we can reorder this in a second. So a quick thing I wanted to let you guys know about. So you might notice that I actually make a lot of horizontal graphs instead of what you're probably taught in school, these vertical graphs. And the reason I do this is because the way computer screens are designed these days is that, I mean, they're wider than they are long. The width is longer than the height. So it makes more sense, and it makes it easier to compare data when you, especially with your bar graphs, if you show it widthwise, and it's easier to compare and see that, you know, this is obviously longer than this one, is longer than this one, is longer than this one, from this angle. So this is actually what I would call a best practice. There is a great book, Storytelling with Data, which talks about how we should actually be using horizontal bar graphs more often than we use vertical ones. That's not to say vertical ones don't have a place, just that horizontal ones are usually seen as better. So let's unsort that data. All right, so what we're going to try and do, as you've probably figured out from the title of the visualization, is we're going to try and find the top 5 players by position. So you can see now we have a pane over here, and we want to find the top 5 players per every position. One way to do this is to use an index column. So create a new calculated field. Let's just call it index, and it will just be the index function. All the index function does is it returns the index of the current row in the partition, meaning in the pane that it's in. Let's make this a dimension. Or, you know, sorry, not a dimension. We want to convert it to a discrete value. So we click on Convert to Discrete. And you'll see this is an example of a discrete measure. And let's put it between position and name. So you'll see it's just incrementing up for every row in our table. And it doesn't start over here. We're going to change that. We're going to make sure it starts over every position group. So right click index. And one thing you might notice is that there's this delta symbol over here. That means that this is what we call a table calculation. These can get quite complicated and they are beyond the scope of this course. But eventually, hopefully you start using them because they're quite useful. So right click index and click edit table calculation. And we're going to want to edit a couple of things. So if you don't see the window, it's probably behind, let's see, put that over there. Oh, it showed up on my other screen. There we go. Yeah, that's one weird thing Tableau does. Sometimes it'll just put windows on separate screens. All right, so this table calculation window, what it does is it's going to, what is a table calculation? A table calculation is basically a calculation that works, instead of working on the data set like most other calculations do, this one works on whatever you're showing on the screen. So these become very useful when you want to sort your data or organize your data in a very specific way. So let us go to specific dimensions. As you can see, there are multiple ways to calculate a table calculation. You can do it, you can calculate it as a value at the cell level, at the pane level where it goes across then down, down then across, or just use the whole table. We're going to use specific dimensions. We're going to have it operate at the deepest level, meaning that it'll increment per position and per name, but I want it to restart at every position per group. So you'll see now, when I come down here, I believe it was like 600 something, it restarts when I go to the next position group. This is what a table calculation is. Basically, it's this index only has a value in relation to this visualization over here. It doesn't have any value, or the value over here is not the same at all. So this is what we call a table calculation. And I want to sort it by custom, value, sum, descending. So now you'll notice what it did is it sorts the table at the position group level. So you'll notice if I go to like the 600s, it restarts when we get to forwards. And you might see what we're starting to do here. What we're doing is that we're now we have a column that allows us to filter on, say, the top 5 players by position. So grab index and drag it to filters. 1, 2, 3, 4, 5. We're going to select the first 5 indices. Click OK, and you'll see Tableau now shows us the first 5 position, the 5 highest paid positions per. Whoops. There we go. Per position group. So that is how we use a table function or a table calculation. And we're using it to rank our marks. So now, next thing we're going to cover is something called dashboard actions. So let's create, actually not a new sheet, let's create a new dashboard. And again, you might want to make this one size it automatically. And let's add in map of countries by player value. Oh, looks like the first thing we need to do is duplicate this as a crosstab. So let's go back here, right click, duplicate as crosstab. And you'll see it just duplicated the table as a crosstab, or duplicated the map as a crosstab. Then let's go back to our dashboard 1. And you can scroll on this bar over here if you're running out of space. Very useful function. Oh, looks like we need to do one more thing. I should listen to my own instructions. Let us add the club value and the name of the player. I think over here, right? Yep, on either side, add all members. There we go. Now for a given club, for a given nationality, we know or we know the player for a given club and nationality. And let's go back to that dashboard we just created and recreate this below by simply double-clicking that and that. So double-clicking map of countries by player value and map of countries by player value 2, which is our crosstab. So actually, let's rename this to map of countries by player value. So actually, we should actually call it probably crosstab of countries, right? There we go. And if you go here, you'll see Tableau dynamically renames it. And like we said earlier, because my window is sized differently now, I need to drag and drop that. Awesome. So this is, again, a very simple dashboard. And what we want to do here is I want the dashboard to limit the size of this table based on what I'm clicking. As you can see right now, me clicking this does nothing to this sheet over here. They're basically independent of each other. So to do that, we're going to use something called dashboard actions. These are incredibly useful, and they will really take your visualizations to the next level, as they will allow your stakeholders to more easily explore the data themselves. Remember what I said. You almost never want to have all of your data just there. The point of data visualization is to abstract away the complexity of data and to show people what they need to see. So, under Dashboard, up here in the menu bar, click Actions. And this menu will come up. Click Add Action. And then click Filter. So these are all the different actions you can add. Basically what we can do is we can tell Tableau for a given action, say I select something, I highlight something, I can have one of these values change. We're going to filter our data. So under source sheets, so source sheet is the sheet upon which the action is where we perform the action, and the target sheet is what the sheet that responds to that action. So under source sheets, let us only select map of countries by player value. Under target sheets, only select the crosstab. Make sure that you run the action on a select, and then it should automatically choose show all values over here when you deselect that. And then we're going to filter on the select on one field, and that field is going to be nationality. Click OK. Click OK. And then now, say I click on Mexico over here on the map, we will see the two players and the clubs that they play for who are from Mexico. And if I unclick, then you'll see it just shows all the data again. This is just a very simple example of a dashboard action and how useful it can be to really flesh out the data you have. So what a stakeholder would do is they would look at this map and they would be like, oh, hey, it looks like a lot of values coming from Brazil. Who's there? Oh, looks like a lot of these players are coming from Brazil and they're valued at this much. And there's a good spread of the teams they're on. Versus, for example, say Iran. There are only 3 players from here, all paid less than probably what looks like the average of the Brazilian players. This is how you can give your stakeholders more interactivity with your visualizations. And this is something I find people like to do. People like to feel like they're, or I wouldn't even say feel like, people like to see the insights that you're showing them. And you don't always know what exactly they want to see. So giving people this flexibility is a tremendous idea and will take your visualizations up to the next level. So one thing you might notice is that these colors are not drastically different from each other. So let's see if we can fix that. In this legend over here, go to the drop down. Oh, and quick thing, this legend over here, we can edit the title. So usually if I don't know what to call it, I just call it legend. Because that's what it is. And you'll see that changes over there. So click on this drop down and then click on edit colors. And you'll see this is the span that we have. So you'll see where the obvious problem is. The problem is that we have countries that are only giving out a player that's worth 70,000 euros to 1.9 billion euros. This spread is what makes it to where our data is not heavily differentiated over here. The colors aren't very different from one another. So let's click on the advanced option, and then we can change the start and the end points to whatever we want. So let's make this 10 million and 500 million respectively. And then we'll make this 500 million. And you'll see the center automatically changes to be in between these two values. And then let's make it a stepped color with 5 colors. Hit OK. You'll see it's a little bit more differentiated now. It's very obvious where a lot of the players are coming from. Obviously, Belgium, France, Spain, and Brazil and Argentina are sending out a lot of players. And if you've watched the Premier League, you'll see why. You'll know why that's the case. But let's see if we can make this even more specific. Go back to your sheet. So let me show you what I just did. You can go back to your sheet by clicking on the tab down here, or you can click over here and click Go to Sheet. This is what I usually use. And then let's create something called a set. So right-click the nationality column, create, set. So by the time you're done with this course, you'll have known how to create all of these things, but we're going to create a set now. And let's name this set Top 10 Countries by Salary Value. Or actually, by player value. So we'll name this Top 10 Countries by Player Value. Let's select the top option over here, by field, top 10, by, I think value is what we want. Make sure that's a sum, and hit OK. So what we've done is we've created a set, and what a set does is it is a value that you can make dynamic through a parameter that creates an in and out group. So every column is either in the set or it's out of the set. So this is a very useful way to filter data as you please. So now you see we've filtered the data to only show the top 10 teams as far as top 10 countries by player value sent. So what I did is I dragged our set from down here all the way up to filters. These are quite useful in larger visualizations when you want to organize your data. And that's it. That's section 3 done for you guys. Thank you guys for joining me. And with that, we've reached the end of the Ultimate Tableau workbook. Thank you so much for watching this video and for downloading my workbook. I really hope that it was helpful for you in getting you off the ground and really teaching you how to start using Tableau. There's so much more to learn, and there's so much more depth to Tableau as a tool. So it looks like we've gone over 3 sections. And in these 3 sections, we've covered what is Tableau, data visualization tool at its core, the importance of data visualization. Every great analysis honestly starts with a good data visualization. What makes Tableau so great? Great customer service and a great user community. These 2 things are things you can read about inside the guide. how to install Tableau. I'm assuming if you came this far, you've learned how to install Tableau. Connecting to static data. So Tableau can also connect to live data, but this course does not go over how to do that because the process for connecting to live data can be really different just depending on your enterprise architecture. So we're not going to go over that in this course. The anatomy of the Tableau data page, that is the page that you use to create your data source. The anatomy of the Tableau workspace, your sheets, your dashboards, your stories. Cleaning data, one of the most important and for sure the most time-consuming parts of any analysis. Dimensions versus measures. Dimensions are categories. Measures are things that you will actually measure. Tables, bar charts, geospatial data, basic troubleshooting, resizing dashboards, saving your work, sheets, dashboards, and stories, and the 7 types of data stories out there. In section 2, we covered calculated fields, especially the date diff function and how to use that. If-then statements, filtering data, and line graphs, and especially this is something that I recommend watching again. The difference between continuous and discrete dates on your graph, very important. Tableau also taught us that we can very easily extract tables from PDF data. So this was something that we learned how to do today. Unioning and joining data. When you union data, you basically stack 2 tables on top of each other. When you join data, you basically attach them at the side. And blending data is when you aggregate tables first and then attach them on the side. So these are the 3 ways you can combine data sources. Aliasing data, basically changing what a column comes out as. So a 1 can show up as a first and a 2 can come up as a second. Splitting columns, defining data types, aggregate measures, that's what we would call this. Editing axes, making scatter plots, grouping our data, using the marks card, adding labels to the ends of bar graphs. This is surprisingly complicated, actually, if you have multiple dimensions in your bar graph. And eventually how to create dashboard actions, sets, and parameters. So at the end of the guide, I've listed a couple of more resources that I think would be useful to y'all. kb.tableau.com, like I mentioned, is the Tableau knowledge base. And this is a tremendous tool for any questions you may have and houses all of Tableau's documentation. Storytelling with Data is the first book that I read on my data career, and it's a great book to get you started on learning how to present data accurately and efficiently. It's platform agnostic, but everything can be very easily applied to Tableau. And actually, Tableau, as a company, applies a lot of the logic in this book in their software. Interesting underwear. Cool function. Makeover Monday. So Makeover Monday is a global movement where I think it's Andy Kriebel and Ava Green, I believe. They are 2 visualization experts. And every Monday, they release a new data set along with a visualization. And participants, anyone can participate, are asked to take that data set and visualize it in a new and interesting way, and then post it on Twitter with the hashtag MakeoverMonday. The Big Book of Dashboards is probably the best resource that I know of in order to actually help you build Tableau dashboards specifically. It goes over good color theory, good design theory, and gives you clear examples of the best practices when designing dashboards. So I highly recommend it as a book. This is one of my favorite books. And then at the end, I'll leave you with something that I call my data checklist, which is basically just a checklist of different things you should check before you start visualizing your data to make sure that you have the smoothest experience while visualizing. I'm going to be adding more to this, and I'm going to be updating this guide periodically. So definitely feel free to check back to see if I've added anything at a later date. As usual, if you have any comments, feel free to leave them down below. And any suggestions on how I can improve this are greatly appreciated. Thank you guys so much for your time, and I hope you guys have a great day. Thank you for learning Tableau.